Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. Ladies and gentlemen, the opening ceremony of the 6th International Conference on Soft Computing and Data Mining, SCDM 2024, University Tun Hussein on Malaysia is about to start. Just a little housekeeping before we get started. Please be reminded to turn on your cameras and mute your microphones to keep the quality of the sounds functional during the event. If you have any questions or queries, especially during the keynote speakers' presentations, please type them into the chat box. I will bring them up to the SCDM committee if necessary. Our virtual SCDM conference 2024 will begin shortly. Bismillahirrahmanirrahim. Rabbi Sohri Sadri wa Yassirli Amri wa Hlul 'Uqdatam min lisani yafqahu qawli. Assalamualaikum warahmatullahi wabarakatuh and very good morning. I am Dr. Muhammad Firdaus bin Abdul Aziz, shall be your host for the day. Allow me to extend a warmest greeting to our eminent speakers and guests, the Honorable Professor Dato Insinyur Technologist Dr. Ruzairi bin Abdul Rahim, Vice Chancellor of University Tun Hussein on Malaysia, the Honorable Professor Dr. Nazri bin Muhammad Nawi, the Chairman of the 6th International Conference on Soft Computing and Data Mining, SCDM 2024, Professor Technologist Dr. Muhammad Farhan bin Muhammad Fuzi, the Dean of Faculty of Computer Science and Information Technology, University Tun Hussein on Malaysia, SCDM, UTHM. Our respected keynote speakers, the Honorable Professor Dr. Rozaida binti Ghazali from University Tun Hussein on Malaysia, Dr. Muhammad Amir Khan, Senior Research Scientist at University of Oxford, and Mr. Azhar-Kasim Mustafa, the founder and the CEO of Nervosis Sdn Bhd. Professors, doctorates, academicians and researchers, ladies and gentlemen, a very good morning. Selamat datang, welcome, and thank you all for joining the virtual opening ceremony of the 6th International Conference on Soft Computing and Data Mining, SCDM 2024, University Tun Hussein on Malaysia. Distinguished guests, ladies and gentlemen, I would like to inform you a brief tentative of our virtual opening ceremony for today. The ceremony will begin with Dua recitations and proceed with the welcoming remark speech by the SCDM chairman. Next, the opening speech will be delivered by the Honorable Vice Chancellor of University Tun Hussein on Malaysia. We will have a short break after all the speeches, and at 10 a.m., we expect the first keynote speech to begin, and followed by the second keynote speech at 11 a.m. Then we will have a photo sessions to close today's ceremony. After that, we will break for lunch, and then the first presentation sessions will take place after the lunch break at 2 p.m. For tomorrow, we will have a session with our third speaker, followed by the next presentation sessions and concluded with a closing ceremony in the afternoon with the announcement of the Best Paper Award for SCDM 2024. Ladies and gentlemen, it is with great pleasure and anticipations that I welcome you to the 6th International Conference on Soft Computing and Data Mining SCDM 2024. This conference stands as a distinguished platform for students and researchers to exchange novel ideas, present original research findings, and share practical experiences in the realm of autonomous agents, multi-agent systems, and also artificial intelligence. With the overarching themes of soft computing for data science, our aim is to foster a collaborative environment that promotes systematic explorations and advancements in this transformative field. We are honored to host esteemed keynote speakers such as Professor Dr. Rozaida Ghazali from University Tun Hussein on Malaysia, Dr. Muhammad Amir Khan, Senior Research Scientist from University of Oxford, and also from Mr. Azhar Kasim Mustafa, Founder or Chief Executive Officer of Neverseas Sdn Bhd. They will undoubtedly enrich our discussion with their profound insights. The conference is proudly organized by University Tun Hussein on Malaysia, a testament to our commitment to driving excellence in research and academia. I extend my warmest welcome to all the participants and wishing the best for engaging and fruitful deliberations throughout SCDM 2024. Thank you. Ladies and gentlemen, let us start our conference with the recitations of Doa by Ustaz Muhammad Isa bin Salikin from UTHM Islamic Center.
Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin wal aqibatu lil muttaqin wala udwana illa 'alal zalimin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, ya Rahman, ya Rahim. Di saat dan waktu yang penuh keberkatan dan kemuliaan, kami telah dipertemukan oleh-Mu, ya Allah, di dalam suasana yang indah, bersempena majlis perasmian persidangan antarabangsa The Sixth International Conference on Soft Computing and Data Mining 2024 SCDM 2024 ini. Kami memohon restu dan mendarahtangan kehadirat-Mu, ya Allah, agar Engkau sentiasa mengiringi majlis ini dengan sinaran keberkatan dan kerahmatan, serta mendapat perlindungan dari awal hingga ke akhirnya. Allahumma ya mujibad da'wat wa ya qadiyal hajat. Kami juga memohon kepadamu, ya Allah, semoga majlis perasmian ini dapat menambahkan lagi keyakinan dan pemantapan dalam perlakuan. Kurniakanlah kepada kami kekuatan mental dan spiritual, agar segala urusan kami dipermudahkan dan segala perancangan kami menjadi kenyataan. Segala idea kami menjadi semakin proaktif dan bertambah efisien untuk masa kini dan masa akan datang. Ya Allah, berikanlah kepada kami kejayaan teras pemangkin rohani. Permudahkanlah medan dakwah kami agar tidak ditimpa gejala merosak diri. Suburkanlah kami dengan budi yang luhur agar di dunia tersohor dan di akhirat diterangi obor ke syurga. Kurniakanlah kami kebijaksanaan berhikmah untuk memimpin urusan agama kami agar ia menjadi umat yang cemerlang, gemilang dan terbilang. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma wa la taj'alillahumma fina wa la ma'ana wa la man yatsba'una syaqiyya wa la matruda wa la mahruma. Allahumma ahsin 'aqibatana fil umuri kulliha wa ajirna min khizyid dunya wa 'adzabil akhirah. Rabbana atina fid dunya hasanah وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين تقبل الله منا ومنكم.
Amin amin ya rabbal alamin. Now, without further ado, please be invited the chairman of the 6th International Conference on Soft Computing and Data Mining SCDM 2024, the Honorable Professor Dr. Nazri bin Muhammad Nawi, to deliver his welcoming remark speech. Please welcome.
Bismillahirrahmanirrahim. The Honorable Prof. Dato' IR TS Dr. Rosairi Abdul Rahman, Vice Chancellor of University Tun Nasional Malaysia, our respected keynote speakers, Dr. Muhammad Amir Khan, Senior Research Scientist from the University of Oxford, Mr. Azhar Kasim Mustafa, Founder and CEO Neversis, Prof. Dr. Rosaida Rosali from University Tun Nasional Malaysia. Distinguished guests, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all. As the steering committee chair, it is my privilege to welcome all presenters, participants, delegates, experts, and scholars in the 6th International Conference of Soft Computing and Data Mining, SCDM 2024. As we all know that today, the role of soft computing and data mining has become significantly crucial in our everyday life. Soft computing and data mining is expected to facilitate and drive innovative ideas for attaining better life quality as well as solving real-world problems. Moreover, the demand for data mining research particularly have never been higher. Particularly, business are grappling with the complexities of big data, seeking to understand their customers, optimize operations, and identify new opportunities. Today, governments are leveraging data to improve public service, enhance security, and make informed policy decisions. Even in fields like healthcare and science, data mining is very demanding. Research particularly leading to breakthrough in disease treatment and scientific discovery. For your information, the SCDM conference is so significant in sense that it starts since 2009 and 2013 by a successful workshop on soft computing and data engineering with various leading international conferences such as database theory and application in 2009 and 2010, ambiguous computing and multimedia applications in 2011, and computational science and applications in 2012 and 2013, where all accepted papers were published in Springer series indexed by Scopus and ISI. Again, this year, SCDM 2024 is host of activity which collaborate between Faculty of Computer Science and Information Technology, SCDM, UTHM, and together with Soft Computing and Data Mining Research Center, SMC, of University Tun Nasional Malaysia. Indeed, we are honored to host the event, and the fact that we are getting more accepted papers and partnership, which indicate continuous support from researchers throughout the globe. This is done by having a collective talent of leading and innovative researchers, developers, and practitioners to discuss on how soft computing and data mining research can generate innovative and strategies strategic and methodologies, concepts, models, frameworks, as well as practical solutions in the forms of products and services for the good of mankind. The conference team has attracted many local and international participants. Just to share with you all that we had received more than 74 submissions from 14 countries, which include China, Taiwan, Jordan, Iraq, Saudi, Indonesia, Pakistan, and Nigeria. To maintain the quality of each accepted papers, each paper in a regular submission was screened by the proceeding chairs and carefully double-blind peer review by 3 reviewers from the program committee. At first, only 50 papers were accepted. 4 papers were withdrawn after accepted, and the other 4 were unknown. And unfortunately, 1 paper was rejected by Springer because of a high similarity. Finally, only 41 papers with the highest quality and merit were accepted for oral presentation and publications in the SCDM 2024 proceeding, with giving an acceptance rates of 71% as compared to SCDM 2022 with 64 acceptance rate. Good news to all that all accepted papers and registered papers in the conference already been published in part of Springer lecture notes, networks and system. And then the best part in our proceeding is that it is already available online via Springer link. For all representatives of authors and accepted papers must personally present their work to this event via online platform. Finally, I would like to express my sincere gratitude to all SCDM 2024 committee members, SMC Research Center, and all staff from FSKTM, and as well as University of Malaysia. Thank you for your hard work, cooperation, support, and commitment in making sure that the SCDM 2024 is organized successfully. Let us embrace the opportunities and responsibilities that come with the data-driven world. Let us invest in research and development, collaborate across discipline, and future and nurture the culture of innovation. Together, we can harness the power of data mining to build a better future for all. Last but not least, I would like to thank you again for being here in this event. I hope your experience at this event would be very enjoyable and beneficial and memorable. I wish the conference a complete success and all the best to all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor, for the welcome speech. Distinguished guests, ladies and gentlemen. Proceeding with today's event, it is a great honor for our conference to invite the Honorable Professor Dato' Engineer Technologist Dr. Ruzairi bin Abdul Rahim, Vice Chancellor of University Tun Hussein Malaysia, to deliver an opening speech and officiate our conference. Please welcome.
Thank you, Mr. and Mrs. Chairperson. Professor Technologist Dr. Muhammad Farhan bin Muhammad Fuzi, Dean Faculty of Computer Science and Information Technology, UTHM. Professor Dr. Nazri bin Muhammad Nawi, Chairman the 6th International Conference on Soft Computing and Data Mining 2024 or SCDM 2024. Keynote speakers, Professor Dr. Rozaida binti Ghazali, Yusitun Hussein on Malaysia, Associate Professor Dr. Harish Drak, Tapa Institute of Engineering and Technology, Punjab, India, Mr. Azhar Kasim Mustafa, Founder, CEO Nervosis Malaysia, participants of the 6th International Conference on Soft Computing and Data Mining 2024, SCDM 2024. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh and a very good day. Good morning and welcome to the 6th International Conference on Soft Computing and Data Mining, SCDM 2024. It is my honor to stand before you today as we gather here at University Tun Hussein on Malaysia to explore the frontier of the soft computing and data mining. First and foremost, I would like to extend my warmest greetings to all our esteemed guests, researchers, scholars, and industry experts who have traveled from near and far to join us in the intellectual endeavor. Your presence here underscores the significance of the conference and reflects our collective commitment to advancing knowledge in these rapidly evolving fields. The theme of this year's conference, Harnessing Soft Computing Techniques for Data Mining Innovations, is both timely and critical in our digital age soft computing, with its emphasis of flexibility and tolerance for imprecision complements the rigorous methodologies of data mining to extract meaningful patterns and insights from vast datasets. Together, these disciplines empower us to tackle complex challenges across various domains, from healthcare and finance to engineering and beyond. As we embark on the next few days of presentations, discussions and collaborations, I encourage all of you to engage deeply, exchange ideas freely, and challenge conventional wisdom. The innovation born from this conference have the potential to shape our future, driving technological advancement and societal impact. Ladies and gentlemen, I would like to express my heartfelt appreciation to the organizing committee, especially to Prof. Dr. Nazrin Muhammad Nawi and team, whose dedication and meticulous planning have made this event possible. The team efforts is outstanding in creating an enriching program and ensuring a seamless experience for all participants are truly commendable. To our keynote speakers, session chairs, and presenters, thank you for sharing your expertise and insight with us. Your contributions are invaluable in broadening our perspective and pushing the boundaries of knowledge. Lastly, I urge each of you to forge new partnerships and collaborations during your time here. The connection you make, the ideas you generate can pave the way of groundbreaking research and transformative solutions. In conclusion, let us seize this opportunity to explore, innovate, and inspire. Together, let us embark on a journey of discovery that not only advances the frontiers of soft computing and data mining, but also fosters a global community committed to excellence and impact not just for Malaysia, but the world of knowledge towards an artificial intelligence or AI community. On that note, ladies and gentlemen, it's a very great pleasure that I officially declare the open of the 6th International Conference on Soft Computing and Data Mining 2024. Thank you, and I wish you all a productive and fulfilling conference ahead.
Thank you very much, Professor Dato in Senior Technologist, Dr. Ruzaidi bin Abdul Rahim. With that, the 6th International Conference on Soft Computing and Data Mining, SCDM 2024, is officially open. Now we will take a short break and then begin the keynote speech sessions when we return at 10 a.m. Thank you, everyone. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, ladies and gentlemen, now we move on to speech segment that is going to be started with the first keynote speaker. Professor Dr. Rozaida binti Ghazali is a professor of machine learning at the Faculty of Computer Science and Information Technology, University Tun Hussein Malaysia, UTHM. She earned her bachelor in Bachelor of Science Honours in Computer Science from University Science Malaysia, USM, in 1997, followed by a Master of Computer Science from University Technology Malaysia, UTM, in 2003. In 2007, she obtained her PhD in Computer Science from Liverpool John Moores University, Liverpool, United Kingdom. Her doctoral research primarily focused on higher order neural networks, where she made significant contribution to machine learning, data mining, and swarm intelligence, optimizations, and also time series predictions. Currently, Prof. Rozaida serves as a principal researcher at the Soft Computing and Data Mining Research Center, UTHM. Her research efforts have been fruitful, resulting in over 200 referred papers published in top-tier journals and conferences. Beyond her research, she has successfully mentored and supervised more than 25 PhD and master students, guiding them to complete their degrees. Additionally, she had contributed as an editor for the renowned Springer book series, a reviewer for reputable journals and conferences, and a steering committee member for numerous international conferences. Prof. Rozaida has led 20 research projects as a principal investigator and participated in more than 14 projects as a team member. These projects were funded by organizations such as the Ministry of Science, Technology and Innovation, MOSTI, the Ministry of Higher Education, UTHM, and also from King Khalid University, Saudi Arabia. Her significant contribution extend to both national and international level, particularly in the field of machine learning and data mining. Here to share her vast experience, please welcome Professor Dr. Rozaida binti Ghazali.
The Honorable Chair of Soft Computing and Data Mining 2024, Organizing Committee, colleagues and researchers, Assalamualaikum warahmatullahi wabarakatuh and good day. I am Rozaida Ghazali from Faculty of Computer Science and Information Technology, University Tun Hussein Malaysia. The title of my keynote speech today is Advanced Approaches to Address Data-Driven Research with Deep Learning. First of all, I would like to express my gratitude to SCDM and the organizing committee for inviting me to deliver my keynote today. I sincerely wish that each and every one of you will be able to gain valuable insights and knowledge from the information that I'll be sharing in this talk today. Okay, well, actually, I always give an introduction about UTHM in all my keynote speech. And I learned that most of you today not from UTHM, so I guess a short brief about UTHM is necessary. So UTHM, we are a technical university and among we are among 20 public universities in Malaysia. We are located in the south part of Malaysia, a very green campus and a very peaceful place to study. UTHM, we offer 8 faculties with more than 120 academic programs ranging from diploma, bachelor degree, master's degree, and PhD. And the niche, the focus of the study mostly concentrates on the area of science, social science, technology, engineering. And the student enrollment of UTHM is about 23,000 with the alumni around 58,000. And the graduate employability of our university is quite high, that is around 96%. This is due to we are technical university, and the hands-on deliverables giving advantages actually to the students, so therefore they can quickly get a job placement after they graduate. So that's all very brief about UTHM. So this is the outline of my keynote today. Right. Here are various architectures of deep learning models. As you can see here, deep learning, they are neural networks with multiple layers, and they are really smart network, and they can understand tricky stuff. Okay, so there exist different architectures of deep learning, with starting from a standard deep learning, recurrent deep learning like LSTM, gated recurrent unit, autoencoder, convolutional neural network, and many more. So these networks, they look very complex, with highly parallel nodes and weights connection. So from where actually the idea of deep learning come from? So traditional neural network, they often referred as shallow neural networks, and the architecture consists of a single hidden layer, or at most maybe a few hidden layers between the input node and the output, between the input layers and input layer and output layers. So these traditional neural network, they have a very limited capability to learn complex representation from the data. So they may struggle in recognizing patterns and relationships, especially in high dimensional and unstructured data such as images, audio, videos, And on the other hand, deep neural network, they have multiple hidden layers which are stacked on top of each other, for example, like this. So this deep architecture allows a deep learning to learn hierarchical representations of the data. And each layer in deep neural network, they extract increasingly abstract features from the previous layers output. So the deeper the network, the more complex and the more abstract the learning process become. Well, the goal of deep learning is actually to find an approximation of an unknown function. So in simple terms, we can say that it involves feeding a computer system with a large amount of data and allowing them to learn. So that is the aim actually. So here, how does it work actually? This is a very simple neural network, but they work the same way with deep learning. So actually we have 2 ways of information, flow here, information flow. First is forward pass and second is backward pass. So these forward and backward process is repeated for many iterations. It can be hundreds or thousands. So how long does it take to train a deep neural network? It depends. Sometimes it may take just minutes, a few minutes, or maybe a few hours, maybe days, or maybe weeks. So depend on the complexity of the data, depending on the complexity of the model, the size of the data, depend on the parameters that we need to tune in the network, and and also obviously depends on the machine that we use. Okay, so in forward pass here, the data is presented at the input layer here. So assuming it can be any type of data, for example, image, text, audio, digit, and any kind of form of input data. So they will be treated as input to the network, okay, and then they will be passed forward to the hidden layer and lastly to the output layer. So here, each of the hidden node will compute the summation of the weighted input, from in between hidden and input layer, and each of the output nodes will calculate the summation of weighted input in between from the hidden layer, and during the training process, the network will learn to adjust the weights. So all these are the weights, the weights in the network they will learn to adjust the weight and biases in order to minimize the difference between the predicted output and the actual output produced by the network. So this process involves, as I said, forward pass, where the input is propagated through the network and output is generated here at the output layer and followed by a backward pass here. Okay, so in the backward pass where the error is calculated, and the error signal will be used to update the weight and biases, of neurons of the weights. So with each iteration, of these processes, the network become better at recognizing the patterns within the data, and they can making more accurate predictions. So that's how basically it works, the way it works. So the deep in deep learning. So the depth in deep learning is actually refer to the number of hidden layers. Okay, like this one, we have 5 hidden layers. Okay, so one problem that usually exists when we have a very deep learning, deep network, is vanishing gradients. So vanishing gradient occurs when the network becomes too deep. It will hit the issue of vanishing gradients. So during the back propagation that I explained in the previous slide, the gradients are calculated to adjust the weights and biases of the network based on the error between the actual and predicted output. So in deep networks, as the gradient propagated backward from the output layer towards the input layer, they can become very small and start to vanish, and as they pass, uh, as they pass through numerous layers, so many layers here, they start to vanish. So when the gradient becomes too small, it can become a very challenging, to update, each of the weights here effectively. So this can lead to a very slow and ineffective learning. So to overcome this vanishing gradient problem in deep learning, many previous research, they have employed different strategies. For example, perhaps they use ReLU or similar or improved activation function that will not allow the gradients to vanish. Or in some research, they start with a proper weight initialization to prevent extreme gradients. In some research, they also apply batch normalization to stabilize the training and the gradients. And some research, they also adjust the learning rates over time to stable the learning. And some also, they consider to use a recurrent type deep learning, such as LSTM and gated recurrent unit. And it has been proven in many previous work, LSTM and GRU, they have overcome the vanishing gradient problem, which I will explain later in the coming slide. So why deep learning and why it's happening now? Mainly it's because of these three reasons: data, hardware, and software. So big data is big business and sometimes becoming big issues. So we have ton of data available nowadays, and data, they keep growing as they never sleeps, they keep growing from terabytes to petabytes. So with this internet, social media, digital content, unstructured data has become a big source of information. In in the real world, we often see unstructured data more than structured data. So structured data is actually easier to manage. Why? It's easier to manage compared to unstructured data, which is very messy and need a more powerful approach to deal with. So major sources of abundant, data may come from like business, web, e-commerce, bank transaction, stocks, remote sensing, YouTube, and many more. The second reason is due because of the hardware. So hardware, there are many technology advancements nowadays where storage cost is getting cheaper and computers become more and more powerful, and superpowered computers, which come with GPUs and TPUs. They can help deep neural network to go faster, to be executed faster. And this hardware also, they can include like specific chips, which offer faster processing, like neuromorphic hardware and quantum hardware. And the third reason is software. Software, we have many free tools nowadays. We have many free tools, and all these factors, they came together. We have many free tools, and these are tools that help us to use deep learning for free, like TensorFlow and PyTorch. So why is happening now? This all big mix of things, all these factors here, they come together at the right time. So deep learning is happening now, obviously, because we have the big data, fast computers, and helpful tools, softwares, and it's proving to be more useful in real life situation. So deep learning is everywhere. It's everywhere. It's around us. We use it almost every day, whether we realize or not, like Google Map, Google Translate, GPT. We do online shopping, on Amazon, watching Netflix, and many more. It's happening around us. So let's quickly go to some of my projects with my research teams. So these are some of the projects. All of these we use deep learning, and the algorithm here we constructed mainly to solve different kind of problems in different field, and most of them we used. So each of these model is to enhance the performance by introducing a modified activation function, or we modify the architecture of the complexity, and to enhance the feature extraction itself, in the deep learning. So for detail about each of these research project, you may refer to the related reference or published article, which I also provide in the related pages, related slide. So the first project is about object recognition. So object recognition is like teaching computers to see and to understand their surroundings. For example, to identify whether this is, to detect or to identify whether this is dog or cat, which they look very similar, and to identify cars, on the road, whether this is a red car, a blue car, or what type of car, in the presence of light and illumination. So actually, in our daily life situations, we already use object recognition, like in our laptop, where the laptop can recognize our face when we sign in, or our phone sort photos, based on what's in them, and it makes them smart at understanding what in front of them. So, for example, training a deep learning to recognize between cats and dog, and whether it's not a dog, or whether the car, whether the car is Honda or Toyota, is it a truck, is it a car, and to identify, to recognize patterns in the image. So another example, about car. And then object recognition is important because it lets computers to recognize object accurately, which helps in tasks like pedestrian detection, checking for problem or defect in products. What else? A surveillance system in identifying potential threats, enhancing public safety, and many more. So the first project, the first research that I'll be sharing today is vehicle detection. So in this project, we introduced a new traffic monitoring system that use a deep learning model, UNet, we call UNet, to detect and categorize vehicles from aerial images. So we address this challenge of increased traffic due to perhaps population growth, such as population growth, congestion, pollution, and accidents. So here we develop a hybrid framework which employs a spatial pyramid pooling within CNN itself, based UNet model, for streamlining the detection, the classification, and tracking the vehicles on roads. Okay, and this obviously will enhance the transportation system management in diverse setting. So the step here involve, first we convert the image, the video data into a series of frame, and then we use the CNN UNet model. We segment each data, we segment each frame one by one. So with UNet model, we analyze aerial image and identify and segmentize the vehicles. Then the segmentize and analyze images we use to detect the vehicles using advanced spatial pyramid pooling here. This ASSP, advanced spatial pyramid pooling, it helps the system to pay attention to tiny details which make the detection more accurate. And after that, we classify the detected vehicles into different categories. And lastly, we track the detected and classified vehicles using extended Kalman filter tracking method. So therefore, the model that we developed, they can help in managing heavy traffic with less need of human intervention. So for this project, we use two data sets. The first is a VDI data set, that is vehicle detection in aerial images. So this data set were used to identify vehicles in aerial images taken in different environments like cities, highways, buildings, and it include image at different resolution as well. I think if I'm not mistaken, there are 9 vehicle categories such as cars, trucks, buses, and many more. And the second one is the LR3K. This is German Aerospace Center data set. So for this data set, we focus on aerial images with a more consistent background of urban and rural streets. So I think for this data set, it has 20 high resolution image and categorized into 2 types of vehicles only, cars and trucks. So these are some results that from this research. Sorry. A comparative analysis we presented here in the first table, which shows detection accuracies across the LR3K data set. From here, you can see that the model, our proposed model, have shown a good detection accuracies that is 93.8 compared to the other benchmark models, you know. And in the second table, we test the data set. We test on V-Day data set, and also showing a very remarkable detection and classification of vehicle compared to other benchmark techniques. So this benchmark study, you can find it here. I put here down the slide. So in both tables here, we're using both data sets. It includes various vehicles in both urban and rural areas, so with complex scenes and crowded backgrounds. So in all detection model, the ASPP techniques that we use have performed differently depending on the data set. Sometimes it struggles with vehicles that have more than 60% hidden by objects like building entries. Basically, in all results here, it demonstrates that our model consistently achieved a superior performance compared to the previous studies, related studies. And so this model, of course, can be applied to other potential applications, such as assessing traffic congestion, analyzing traffic density at intersection perhaps, or differentiation between vehicle types, determining pedestrian pathways, and many more. So for this research, you can find the details in this paper, which just published in Journal of Sustainability. So the next project on object recognition is bilingual handwriting recognition, which published in Knowledge Based System. For details, you can refer to this paper. So for this project, handwriting recognition, actually they transform handwritten text from paper or digital content into digital format, so making it editable and searchable. So it is used in many applications, for example, processing of checks, mail sorting, verifying signatures, managing medical records, processing form, and many more. So it's quite challenging. Because the writing style of one same writer varies different, you know, from instance to instance. For example, Arabic and English handwritten. In some language, they are considered as a second language in some countries due to religion, educational, or social reasons. So due to that, most of the documents in Arabic states, they are typed, they are prepared in bilingual forms, okay, mix of Arabic and English. So here is the example, you know, this form to be filled up by the filler, the applicant in bank account application. So you see here, the first form, the filler fill up using full Arabic, you know, Arabic, they write in Arabic, and the second form they write in Latin, in English, and the second form, the filler fill up the form mix of Arabic and English. So this is what we want to address now, bilingual handwriting recognition, how to recognize it. So in this work, we use a CNN, convolutional neural network. So this is the optimum topology of our model, which composed of 15 layers or 15 blocks of CSLBP convolutional layers. CSLBP stands for Center Symmetric Local Binary Pattern Convolutional Layers. So this network, we recognize digit using low-level features like simple patterns, edges, textures. And for high-level features, for example, abstract or unique patterns and complex shapes of the of the digit. So throughout this network layers, low-level features, they are combined to form high-level features, and this enable the model to accurately identify whether an image contains, for example, is it number 2, or is it number 5, or is it number 9. So what again, this research, we improve the LBCNN, the local binary CNN, by we fuse it with a center symmetric LBP, and we call it SCS LBCNN, and this is to detect the edges of digits accurately. And after that, we also enhance the CS LBCNN. We apply the non-zero threshold values, and then we call the algorithm, the model, as threshold, this one, threshold center symmetric local binary CNN. Okay, so the data set that we use here, we use three data set. First is the English or Minis data set, for example, this one, and then the Arabic data set, and then the bilingual data set, okay, which combine both Arabic and English data set. The size of the image is I think it's 20 times 20 pixels and normalized into 28 pixels. So in this table here, it shows the comparison using bilingual data set. Okay, we also benchmark the results of our models with ResNet and LBC and AND. Okay, as you can see here, both of our proposed model outperform the benchmark CNN models. So the CS, LBC, and AND, actually we use a filter in the CNN itself. Okay, this one created by we create it by fusing the center symmetric local binary with a CNN. So we reformulate the center symmetric LBP as a convolution layer in the network. So additionally, we applied a non-zero thresholds in the model by changing the weights of the CSLBP layers, right? So this is another result which we compare our model, our proposed models here with quite many previous works in using the same data set. On this one is on Minis data set, and this results on Arabic dataset, and this is on bilingual dataset. In all tables, as we can see here, our proposed model outperform other models in terms of the percentage of accuracy. Now, the next research that we use deep learning in is on healthcare. So using deep learning for medical diagnosis means letting computers to learn from a lot of medical related information. Okay, there are some challenges actually associated when we use deep learning on when we want to do research in healthcare data, because first is because healthcare data, they are very large amount, of data. So it's manually impossible to process, and we need longer time to diagnose and to get the results and sending to the lab. And in terms of resource information, we need more staff, machines, tools for laboratory tests. Because deep learning, they can learn fast and they can help doctors make smarter choice, which is really helpful for patients. So deep learning, they can help to find very tiny details that doctor might miss perhaps. So therefore, it is important to utilize, to employ deep learning here, because it can help doctors to read medical image more accurately and can catch illness early, which give and can give better treatments, obviously. So first, there are other research, but in this speech, I just share on one data set, one research field that is we predict stress, stress prediction using our proposed deep learning model. So this research, you can find details in this journal, Brain Sciences. So we already know that the continued presence of stress, okay, it can lead to bad health effects such as high blood pressure and depression sometimes. And this chronic stress, it can result in, surprisingly, it can result in cancer, heart disease, and mental health issues, and diabetes. So developing a robust method to detect stress is very important. So that we can identify and control the stress at early stage, and then we can prevent stress related illness like like mental health issue, diabetes, and so on. So in this work, we develop an attention aware deep learning model, where in this model we incorporate attention mechanism here in the network. So the concept of attention is borrowed from human cognition, where sometimes, where we as human, we allow attention to be given to, we focus on specific parts while at the same time we ignoring others. So in the context of deep learning, attention mechanism will enable our models to selectively focus on certain parts of the input data, while it gives less attention, less importance to different elements in the data. And for this model, we also utilize LSTM to predict stress level. And LSTM is a type of a recurrent deep learning model. Therefore, LSTM, it has a special characteristic, special properties, because it's a recurrent type network. So it can retain the memory in the network. It can have memory of past, current, and it can have memory of past, present, and future. So any type of recurrent neural network, they can use previous signal, previous information to process the current information in order to forecast or to predict the future signal or future data. So that is the unique properties of recurrent neural network. So it's very good also in handling vanishing gradient issues. So LSTM, it has 3 gates. There is forget gate, input gate, and output gate. So in short, forget gate is used to decide whether to decide which information to discard from the cell state. Meanwhile, we use input gate to determine which new information to be added to the cell state, and output gate is used to choose which information from the cell state to output as the hidden state. Okay, so in our work, we use this model, we call it ELSTM. This model allows the gate layers to look back at the cell state by adapting the peephole connection. So this peephole connection completely influences the gating mechanism itself. Then we combine the LSTM with feature attention mechanism here, and we utilize both pre and post attention post feature attention layers here in order to obtain a more comprehensive feature representation. So data set that we use for this work, we obtained from Korea National Health and Nutrition Examination Survey. The parameters that we considered come from different features like physical activity, lifestyle data, including sleep time, body mass index, smoking, and a few more. So the outcome from this research, we compared our model with some other baseline model here For example, standard LSTM, deep belief network by LSTM, SVM, and so on. So the accuracy of our model, as you can see here, greatly impacted, by the use of attention mechanism in the model, which directly affect the performance of the model. All right, the next research field that we explore is natural language processing. NLP is actually a technique that helps computers to understand and interact with human language. So NLP, it allows computers to read, to interpret, to respond to text or speech. So making it possible for us to communicate with machines in a more natural way. So most of us actually, we use NLP in our daily life. Okay, for example, Google Translate, it use NLP technique, chatbot, search engine, what else? Grammar correction software or voice assistant, ChatGPT. Okay, ChatGPT, it use transformer, deep neural network, for your information. So in our work, we use NLP for text classification and sentiment analysis. So the first one is on text classification. So text classification here is used with a wide range of digital content to identify customer sentiment and also to analyze speeches of, for example, political leaders, or we can also monitor hate and bullying on social media platforms and many more. So another example is filtering spam to spam or non-spam email. So both Google and Microsoft, they use deep neural network to identify spam in emails. We might aware that you might witness that in our mailbox a few email is missing. As the service provider, they filter some unwanted emails. Using this technology. So in this work, we use a gated recurrent unit. Gated recurrent unit is another type of deep learning. It's also a type of recurrent deep learning, almost similar with, very similar to LSTM, but it only has 2 gates instead of 3 in LSTM. So in this work, we use GRU together with autoencoder deep learning. So GRU only has 2 gates here. That is update and reset gate. So in this research, we try to challenge 3 issues. First is high dimensionality text data. So the solution, what we did was we used an autoencoder, okay, autoencoder here, which the autoencoder, it compressed the data into smaller representation using encoder first, and then it will reconstruct using decoder. Okay, decoder in the data to reconstruct the data back from the compressed version to the original format. So the second issues that we try to handle is the redundancy and complexity in the GRU node itself. Okay, this is GRU here. So what we did was we replaced the reset gate in GRU with another update gate. Okay, why we did this? In order to reduce the redundancy and complexity in the unit. The third issue is high computational complexity and running time. So we use batch normalization. Okay, in this case, we use batch normalization in the training in order to speed up, in order to boost up the training procedure. So for this work, we use 7 data sets here, 7 data sets, which 3 of them are news data set with different news categories. And we also use a Yahoo, this news got various question and answers posted by users on Yahoo Answers. We also use review Amazon review data set and customer review data set. So there are 7 all. So for customer review data set, example, This figure here, this is an example of a customer review data set. When the customer review when they buy a new phone, okay, when they buy a new phone. So you can see here what one of the reviews said: faster, good quality camera and the fingerprint, blah blah, and love the cell, very good, one in everything. So for us, it's easy for human to understand the emotion in the reviews given, whether it's positive or not, whether they like or not the phone. But for computers, for a machine, we need a smart algorithm for the machine to understand or to identify the emotion the reviews given. So here are the results. As you can see here, our model down here has, in terms of the time complexity, it take much less time compared to other models like CNN, autoencoder, LSTM, GRU in executing the task. And in terms of the accuracy also, our model have outperformed the other benchmark model. So therefore, what we can say, using GRU in combination with autoencoder and also batch normalization, and it helped the network to capture significant features from huge data set and tell if the message is positive or negative. Okay, that is on text classification. The next research is on sentiment analysis. You can find the details in here, published in Multimedia Tools and Application. For sentiment analysis, it is used to determine whether the data is positive or the data is negative or neutral. So it helps the organization, it helps us to understand what actually people think about certain brand, about certain product and services provided by the organization or company. So the model that we use here is a two-state GRU. We call it STS-GRU. This model is again based on feature attention mechanism, which this model focuses and concentrates on identifying the sentiment polarity using sequential modeling. So it integrates the pre and post feature attention in the model. So the forward, okay, if you see here, the forward here, the forward GRU, these are all the GRU unit. The forward GRU, it computes from left to right, okay, context on the sentence. Meanwhile, the backward GRU here, it process from right to the left context into consideration. So then these two forward and backward contexts, they are combined into a single context. So the data set that we use is IMDb, the Internet Movie Database, MR, and SST2. So all these are kind of movie reviews data set we collected from different database. The first data set is IMDb. It consists of for example, this one, of about 50,000 movie reviews, okay, which is labeled as negative or positive, in which you can see here the overall sentiment or opinion as given by movie watchers. Okay, for example, here, basically there is a family where a little boy, I thought this movie did a downright good job, and so on. So we categorize them into positive or negative. So sentiment analysis in the movie, in movies, is quite crucial to understand. Why it is important is to understand audience reactions and preference when watching movies. So this can offer a good information, a good insight to filmmakers, for them to improve their marketing strategies, to improve the content of the movies, and to predict box office success. So in simple words, sentiment analysis, obviously, ultimately, it can improve cinematic experience and align better with audience expectation. Now, the next research we did is in environmental modeling. Um, uh, as we know, deep neural network, they are a very smart algorithm, so they can find patterns in big sets of data easily. So using deep learning in environmental modeling, it can help us to predict things better and understand tricky connections in nature, and quickly, if we can notice any changes, we can do we can take a precaution things, and we can use resources smarter and make good decision. So overall, it helps us to predict what might happen and make better choice to take care of our planet. So not only that, it also helps the related authorities in making decision in their policies. So what we did in one of our research in environmental modeling is water quality prediction. So water quality prediction is important because it helps us to keep our water safe to drink and protect our environment. With water quality prediction, it also helps us to monitor for any risk of pollutions in water, and this way we can take action early to keep our water safe and healthy for us, for us people, for the plants, and also for animals. So the challenges is that the complexity of water quality data, which is they are very dynamic in patterns. They have many noise, missing data as well, and variations in sensor reading. So the solution that we provide in this research is that we address the challenges of overfitting the convergence speeds in the GRU. We use a gated recurrent unit here, and we introduce a new activation function, which we call it as SGLU. Okay, so SGLU is the fusion of two activation function, that is GLU and CLU. So we infuse these two. We fuse these two, and we come up with a new activation function as GLU. So we take the advantage of CLU in gradient stabilization, and the strength of GLU in faster convergence. So this new SGLU, it offers enhanced data representation. It also enhances quicker model training and effective handling of complex pattern in water quality data. So for this research, we use a data set from Hong Kong rivers and Canadian station. This is an example of the data set. For some of the parameters like biological oxygen demand, BOD, dissolved oxygen, and ammonia, nitrogen. So the ability to identify complex relationship and patterns in the data is introduced, with the use of our new model here. So as you see here, the results accuracy versus validation for Hong Kong rivers using our proposed GRU model. This is the results, of a different activation function. This is our new activation function. Okay, we compare our model with other deep learning models, SCDM, Transformer, and CNN, using 3 different activation function. Obviously, our model with the proposed activation function give the best results compared to other models. All right. Next, on time series forecasting, we also use deep neural network for time series forecasting. So time series, they can be found in many disciplines, and they can be collected in seconds, or they can be collected in minutes, or hour, or month, or year, indeed. So most of time series signals, they are very difficult to forecast. Why? Because they consist of, they consist of these non-linear, complex and chaotic patterns in the signal. And why it is important to do time series prediction. For physical time series prediction, when we do physical time series prediction, it can help us to prevent undesirable events by forecasting the event, and therefore we can taking corrective action so that the event can be avoided, or at least we can lessen the impact of the event. And for financial time series prediction, of course, we want to make profit. We want to profit from the, we want to do, we want to make some profit from the forecasting itself. So this is time series forecasting, how it works with deep neural network, where this is, for example, the signal itself, the time series signals. So we're going to take one window of the input. For example, we take the signal from Monday until Friday, for example, Monday until Friday. We pass it to the input layers, okay, and then we ask the network to predict what is the value of, what is the signal for Saturday. So the input here from Monday to Friday, we ask the network to predict what is on Saturday. So the input is given from X at time T until X at time T minus S, and we want the network to predict what is the value for XT plus 1. This is future prediction, future forecasting. Then we compute the error here, and then we adjust the weights accordingly. Okay. That is how basically it works with financial time series forecasting. So for this research, the first one is we use stock market crisis forecasting using Karachi Stock Exchange 100. Financial forecasting is actually among a difficult task due to their complexity of the financial system itself. You know, there are many time series maybe can be approximated with quite high degree of confidence and accuracy. However, financial time series, they are found among the most difficult to be analyzed and predicted. Why? Because the up and down movement, you know, which is affected by many factors such as political and economic, and these factors they interact with each other in a very complex fashion. So stock market, they can collapse, you know, they can collapse. Stock market collapse, they occurs when stock price they drop by more than 10%, for example, across all main indexes. So, and these caused by a variety, many factors, okay, variety of factors like including corporate results, geopolitical tension, financial crisis, or maybe pandemic events. So in this work, we use two deep learning models, that is GRU and LSTM. Again, they are type of recurrent deep learning where they have memory of the previous signal, previous information to be used to process the current information in order to predict the future data, the future signal. Therefore, GRU and LSTM, they are very suitable to learn data that have dynamic behavior, in which the stock price of today can affect tomorrow's price, right? So here we use Karachi Stock Exchange 100. So these are the list of stock financial attributes that we use. We examine 45 different KSE 100 stock financial attributes, and these are the how the attributes, how the input is passed to the network. We develop a model for the prediction here using a hybridized feature selection. We call it as HFS approach. First, we use a HFS method to remove unnecessary stock attributes, and after that we use naive Bayes. We use naive Bayes to classify strong fundamental stocks, and then we use stochastic relative strength in index to identify the stock price bubble. Next, we predict the stock crisis by using GRU and LSTM. Okay, so this approach, the framework here, the HFS-based GRU technique, outperform HFS-based LSTM method in predicting the KSE stock crisis. For details, you can refer to this paper in PLOS One for this research. Another financial prediction that we did is on Hang Seng Index. Okay, we propose to combine the architectures which we take the advantages of CNN together with GRU simultaneously for the prediction of these trading signals. Okay, this is an example of Hang Seng Index. So we use 8 years data points of Hang Seng Index, HSI, and also DAX and SP500 index. So this data is presented at the input layer of this model, and we call it as a recurrent CNN model. So and then the convolutional layer here, we have here, and directly fed into the bidirectional GRU here, where here we have forward and backward mechanism in the bidirectional GRU, and we evaluate the ability of the network as traders. Okay, the network now become trader, and we also evaluate the performance of the network based on the percentage of annualized return. So this measure, annualized return, is actually a real trading measurement which is used to test the possible monetary gains, and to measure the overall profit in a year throughout the use of buy and sell. Okay, buy and sell signal. So experimental results here shows that the proposed GRU CNN, okay, the blue one here, obtain the best prediction accuracy. And also here, okay, in terms of the accumulated normalized return, our model have gained the highest return and highest in gaining the profit. Okay, last application field that we employ DNN is in recommendation system. So recommendation system, with a recommendation system, shoppers, okay, like us shoppers, we can get benefit from this enhanced discovery, from reduced decision overload, and also we can save a lot of time, and we can have a personalized online shopping experience, okay, with recommendation system. So before recommendation system exists, online shopping involve manual searches, manual search, limited discovery, lack of personalization, and decision overload, and we may take a very long time to decide what thing to buy. Okay, other than personal shopping, we also use a recommendation system for in Netflix, Spotify, Amazon. Okay, Amazon, they use all this, they use complex algorithm, a combination of deep neural network and other machine learning algorithm. So basically there are two types of recommendation system. There is a content-based and collaborative filtering. So content-based is actually they recommend items similar to those the user has liked before. Okay, based on the item features and that user preferences. Meanwhile, for collaborative filtering, it recommends the item based on the preference of similar users. So it will leverage patterns in user behavior and interactions. So the challenge, mostly the challenge when we work in recommendation system is these two. That is cold start and sparsity. These are two significant challenge in this area. So cold start in a recommendation system is actually it happens when a recommended system, they struggles to suggest things for a new user, okay, for a new user or item with little history. For example, I can give you an example. For example, when someone just joined Netflix or Spotify, okay, the system might not know their taste, what their preference yet, what movie they like to watch, what music they like to learn for a new user. That is a cold start. Meanwhile, sparsity in recommendation system is when the system has mostly empty information in its data, like a big online store, for example, with lots of products, but only few people come and buy. So this make it hard, to guess what people might like, because it's a new store. Not many people yet come there. So therefore, we need a deep learning recommendation system, which can use different tricks, even when there is not much data about users and item. So what we do in this product recommendation. We use a hybrid approach. So we hybrid both content-based and collaborative filtering. Here we design a multimodal data embedding and deep transfer learning, and we integrate them for effective and personalized product recommendation. So here, item feature vector were extracted using a pre-trained deep learning model, VGG16, while user factor we use word-to-word embedding technique. And lastly, a top n items is generated by combining for example, fifth or 10 tops item from item similarity matrix and item from similarity clusters. So for this work, we use two data set, that is fashion e-commerce product data set and Brazilian e-commerce data set. So some of the results here, our multi-model deep transfer learning has outperformed baseline recommendation system in terms of accuracy. Okay, this is in terms of the MAE, and this is the scatter plot. In terms of the accuracy and the performance improvements for both sparsity and cold start challenge. So results on Brazilian dataset shows the error steadily. Okay, this is results on Brazilian dataset, shows that the error here, mean absolute error, steadily decrease over time. Okay, steadily decrease. And average rating by customers is presented here in scatter plots. So literally, businesses, they need to understand customers' views on their product or service, for strategic marketing. So companies, they need to analyze the customer reviews for better businesses. That's why we see that the deep neural network recommendation system are becoming more and more significant nowadays. So we come towards the end of my speech. Deep learning, remarkable features. Deep learning remarkable features, their remarkable qualities have become a very powerful force in AI itself. So if we use deep learning if we use it with transfer learning, it can boost adaptability to diverse data types. And if we use it with parallel processing, it enables to conquer any challenges. So in essence, I can say that deep learning, it reshapes AI advancements. So basically, whether we use deep learning, whatever we use deep learning for, the main purpose of employing the algorithms are either we want to reduce the model complexity or to reduce the processing time, or we use it to efficiently optimize the parameters or efficiently optimize the architecture of the model, or we want to improve the model performance, increase the prediction accuracy, or we want to reduce the prediction or recognition errors. So basically that is the main aim, when we use deep learning algorithm. So one thing that we must remember, deeper, the more deeper, deeper is not necessarily better in deep learning. So data and model, data and model power, they must go hand in hand. So very deep models with many parameters, it will require a lot of data to be well tuned. So if we don't have enough training data, um, our powerful model will easily overfit the training data, and this can lead to a very low training loss, but will most probably perform poorly on the test or production data. So that's one thing that we need to bear in mind. And open research and future project, there are few here. First is few shot, which we can consider for future research. First is few shot and zero shot learning. This is where we train the models to handle tasks with few or no examples at all. So that's why it's called zero shot. The second one is energy efficient models, where we can design the models that perform well while using less energy. The third one is on neuro-symbolic integration, where we can merge deep learning with symbolic reasoning. The next one is meta learning, where we can create models that quickly adapt to new tasks with little data. And the last one is quantum deep learning, where we can combine deep learning with quantum computing to solve complex problems. So these areas just represent a fraction, okay, a fraction of the ongoing research and potential future directions in deep learning. I believe as the field evolve, I believe the new ideas and projects will continue to emerge. So obviously, deep learning is really important because it is used in many areas and is a big part of AI technology. And companies, they tend to recruit people who know deep learning, or at least AI, because it helps them, the company, to make better product and services. And in fact, most businesses, they have an AI strategy, and they start developing their own AI talent. So while this area is one of the hottest in software industry, so some businesses find it difficult to hire talent, to hire talent due to the shortages. So I guess this makes it a perfect time to everyone to explore deep learning and become one of the in-demand experts in this field. So what to expect in the coming years? As a conclusion, deep learning, it has a very high potential to revolutionize a wide range of industries and organizations. We can expect to see even more and more transformative changes in the coming years. With that, thank you. And I really hope that this talk benefits every one of you. And thank you again.
On advanced approaches to address data-driven research with deep learning. Hope everyone enjoyed the talk and broaden your view and knowledge on the advanced approaches applied in artificial intelligence research, especially in deep learning algorithm, either in a basic life necessity, prevent pollutions and environment sustainability, stock market forecasting profits, and also in healthcare. Distinguished guests, ladies and gentlemen, now we are entering into the second speaker segment of today. Dr. Muhammad Amir is an experienced computer science professional specializing in artificial intelligence, machine learning, and data science. He holds a PhD from University Tun Hussein on Malaysia, where his research focused on advanced machine learning techniques. He is currently a senior research scientist at the University of Oxford. He also one of the affiliate data science researchers in Derby University. Dr. Ame is leading the AI-based project for wildlife conservation, leveraging cutting-edge technologies for global biodiversity monitoring. His career includes significant roles as an artificial intelligence and machine learning development engineer at the University of Derby and as a principal data scientist, where he developed innovative solutions for integrated AR or VR and data science. Dr. Ame is also an experienced educator, having taught at institutions like at the University of Wales of Scotland and in University Tun Hussein on Malaysia. His contributions to academia are highlighted by numerous publications and his active role as a reviewer for prestigious journals and also as our second speaker segment for today. Now, without further ado, please join me to welcome Dr. Muhammad Amir Khan to deliver his speech entitled The Use of Deep Learning in Industrial Applications. Are we prepared for that? Please welcome, Doctor.
So first of all, I would like to thank to the whole committee of the SCDM, especially Prof. Nazri and Prof. Rosaida, to giving me this opportunity to be a keynote speaker for this this beautiful conference. So I would just introduce myself for in a few lines. My name is Muhammad Amir. I'm currently a senior research scientist at the University of Oxford. So when I know that I will be the keynote speaker for the conference, so the things came up to my mind that what should I do and what should I talk about. So it came to my mind that why don't I go for the things that I have been through. So my journey started from one of the computer science labs in FSKTM, UTHM, and then it's now ended up in, it's not ended up, but it's still continuing at the Industrial Research Lab at the Department of Computer Science at the University of Oxford. So all this journey that I have been through for the last couple of years was, all my motivation was towards the AI in industrial research and industrial applications. So I thought, why shouldn't I choose this one, and why shouldn't I talk about the experiences that I have been through? So that's my topic today, is the use of deep learning in industrial application. It's a very generic word, a generic thing that to talk about, because nowadays a lot of people are talking about that. But I would be just talking about my own experience and the projects and successes that I have got during my journey. So let's talk about the AI in the AI in industrial research or industrial development. So the question from that sentence arises that we need to explore the future of artificial intelligence in industry, and are we prepared for that? So to answer that question, we need to go through a few steps and discuss the things that that will tell us that are we prepared. If we are, how we get prepared, and if you're not, what are the things that we need to um, prepare ourselves for? So yeah, I would just go for a normal, a very brief introduction of the deep learning in its growing significance in industry, because nowadays I would say that all in the like I have been in a lot of conferences and seminars and talks and meetups in across the Europe. So I say that 60, 70, more than 70% of the fundings and grants and research are moving towards the Industry 4.0, which is based on industrial automation. And when we talk about industrial automation, the main subject is AI. So, what is AI and what is then deep learning? So, deep learning is actually a subset of AI focusing on the generic neural networks with multiple layers. So there are a bunch or hundreds of definition of deep learning, and everybody have their own definition according to their own needs. But as a generically or as a computer scientist, we know that deep learning is just another form of AI or machine learning algorithms, but with multiple layers. So, because if you take any deep learning approach, any until now, even the latest one, they have two main qualities from the starting, which is very old AI. There will be a neural network in there, and then they will have multiple layers. So the core concept of that is actually they will have layers, and then they will have be a network connects of neurons. Though that in the modern AI or modern algorithms, which we call deep learning, the algorithmic structure will be different. Either they will have different mathematical structure or implementation structure. They will be different, but they will still have layers. And then it has the potential to revolutionize the industrial applications. So um, from the perspective of starting development or manufacturing towards the end, which is maintenance. So anything starting from manufacturing until their maintenance is all around machine learning and AI focused in the industry 4.0 or the modern industry. So that's just a brief introduction of industry and AI with deep learning. So as we go deep from AI towards deep learning, so I know there's a computer science conference, and a lot of people might know more better than me about the deep learning and the AI. But what I just put an image which is actually a self-explanatory image, which shows the difference between old machine learning and a new modern machine learning, which is called deep learning. Because in what happens in old machine learning algorithms, that we still need a, a human or another algorithm which helps the actual machine learning algorithm in post-processing and pre-processing. So for example, feature extraction, feature ranking, feature selection, we need to use algorithms for that. And then once all the features are clean and clear and prioritized, then we move towards the actual machine learning to give us some output. But as an advanced machine learning algorithm, which is called the deep learning algorithms, we don't do anything. We just give the input and we get output. It is actually an intelligent approach which do all the processes which we had previously in machine learning. It do it by itself. So like it it extract the feature by itself, it rank them, it selects them, and then it's classify them, or it's then take decision based on that one and then move forward. So that's a very slight difference between a normal machine learning algorithms and a deep machine learning algorithms. So but yeah, if we go for deep learning algorithms, again, they are based on neural networks, artificial neural networks. The last two steps, which are different from the normal machine learning algorithms, are they are capable of processing large amount of data. So if we go for a machine learning approach, the data that it takes is quite low. If we go for a higher data, you will stall the algorithm, or you will hang the algorithm, or it will hang your hardware. So on the opposite side, if you take a deep learning algorithm and you don't have a large volume of data, it means you're just wasting your processes and wasting your time, because deep learning algorithms are not working on low amount of data. So if you have, for example, you have like 50 or 60 features or less than that, and you have hundreds instances or a few hundred instances, and you want to work with deep learning algorithms, that's not gonna quite work for that, because we need a lot of data for deep learning algorithms. So that's one of the good feature, because currently we have a flood of data everywhere, from social media, from census, from marketing perspective, from e-commerce, from automotive industry, from aviation industry. So we have a lot of data, and we need something to process it, and that's actually a deep learning. And then the third approach, which it follows, is some self-improvising or self-improving models. So what the capability of deep learning approach, which called currently we call them generative machine learnings or generative AIs, that actually they learn from their own mistakes. So for example, they take a decision, and then from experts point of view, the expert says, no, that's not quite right, you shouldn't take this decision. So then it take back that result, that take back that the output, and then reconfigure itself to go more, or to get learn the data. So it's the same way that when we are driving on a road, so when we drive for the first time, we don't know the road, we do mistakes, then we go for second time, then we go for third time, and then we learn from our mistakes. And it reaches to a time where we drive without looking, because we already know the road or the way quite easily. So that's how this algorithm also learns from its mistakes and go forward. So coming back to the original topic, which is actually the industrial application of AI or deep learning. So I just took four of the major industrial application, which practically I worked on, and I learned from these approaches, was the first one was predictive maintenance. I will be talking about them in details, and so the other aspect is quality control and defect detection, robotics and automation, and supply chain optimization. These, like, though we have hundreds of applications of a deep learning in industries, but I can't talk about all of them due to the time restriction in my knowledge to them, because these application I have practically worked on them, and then I made them live. So that's why I chose these four topics. Going to the predictive maintenance. So for the first, when I joined the industrial research within the UK, actually it was in the University of Derby, but it was backed by Rolls-Royce. So in predictive maintenance, actually I can't share the actual photos and the actual framework of the for the whole project that we developed because it was restricted. But still, I can talk about it. I cannot share it, the images and data, but I can talk. So, what we did is actually Rolls-Royce is actually building the engines for the jet engines for the fighter jets and normal planes, and so what they did is they once they develop any engines they have every 5 years and then yearly wise services for these engines. So they wanted to have a system which tracks the records or which would store the records of each service of the engine from the starting when it was built, and then every year the services extract the records in the form of videos and images and text, and then it's taking all the wears and tears and any cracks or any color distortion on any deformation and on their shape or size. So they just take all of these in their system, and then based on that records they say that this engine part's going to break in the next 1 year, or you need to repair it before it breaks. So that's how the whole the project was quite deep and it had a lot of functionalities. But again, it is restricted, so I can't share. But yes, that was one of the predictive maintenance project that I have done, and it was having 80% of AI used in it. So the rest was just processing data in terms of extracting knowledge, in terms of ontologies or knowledge graphs. But yet but the end of day, we were processing images and videos to find out the cracks, wear and tear, and deformation in the object size or the assets or the engine parts. And then based on that, we say that this part gonna be break or something's gonna happen to this part before it happens. So that's one of the example of predictive maintenance where we used AI in it. So the second one is quality control and defect detection. This project is also supported by Rolls-Royce with University of Derby, but there was a third party, which is actually Minister of Defence, or we saw aviation industry in the UK, mostly British airspace. So what they do is once they're building the parts, they already have all the actual data of the parts, and then during building they have a lot of, it's like high dimensional cameras and sensors and everything. So when the parts are building, it's actually it's like it's tracking the parts, that is there any defects coming during the manufacturing process. So when a because most of the parts when they're building in a closed chamber, you can't see them. It's some sort of like an example of 3D printing. So when it's printing, you don't know what's going to happen to the part. So so we had a lot of cameras, thermal cameras and high dimensional cameras with sensors, which is actually feeding data into an AI algorithms, and it's actually in identifying real-time defects. So it says, okay, yeah, the diameter is a few micro meters wrong, or anything's going wrong. So before that defects, so before that parts completely build and come out, and then we know that okay, it has defects, we know it during the building process, so we can stop the building process, so we can stop the cost of manufacturing, or we, if it is recoverable, we can fix it and restart the system. So um, that's one of the high level project which we have done for quality control and defect detection in manufacturing for high or expensive products, the manufacturing products, which are again it's the aviation industry, their jet engines or fighter jets or even the submarines parts and their all assets. So and this system, both of the system that previously we discussed and now the predictive maintenance and the quality control and defect detection is live there. It's in testing phase now. The third was robotics and automation. I did work very little on this project, but I did work 25% of my time was allocated to this project, which I was leading. So we had multiple engineers, researchers, and scientists in that one. But what we do is in that one, it is actually backed by JCB, which is one of the big manufacturing or machinery manufacturing industry within the UK and US. So this project was backed by them, in where we develop robots for manufacturing capabilities. So because the human eye is not that much accurate in terms of measurements, so we implemented machine learning capabilities within the robots, which helps during manufacturing. So during manufacturing process, it can measure the parts or measure the any products that are under build or which is already built, but they want to verify it's correct or not. And then it's just differentiate between the corrected parts and new parts and old parts and all these stuff, and then pack them in a proper way and then put them in their proper place or proper shelves. And personally, when I visited that industry, I couldn't see the second end or the last end of the on the factory, because it was very huge, and all the processes were so complex. So what happens is they say that we lost almost 4 million pounds each year only because of human-made errors, uh, and they wanted to invest that money into develop robots which could help humans in decision making. So that is one of the also one of the hot topics currently in the UK, Europe, and the US, which is robotics and automation. Because it's like if we work with the robots, the factory is going to go running for 24 hours non-stop. Because currently now we have shifts, and then of course humans they make mistakes. So yeah, this is one of the key industry that I had worked on, and which is a hot topic currently. People are getting a lot of grants and on these things, and a lot of big industries supporting universities and stuff to do research on this. The last one is supply chain optimization. It is actually a project that is being supported by National Gas, which is actually an oil and gas company. It's one of the biggest oil and gas company in the UK. So they want to use an optimized process for their supply chain for their all inventory managements and route optimizations, because their products are transferring from not one single country, but from a whole continent to another continent and across the globe. So they want to have a system based on AI to tell them what is the best way, which is the best route, which is the best season, and which is the best time to transfer stuff, or to do all their inventory managements, uh, product shifting, because these industry, their product is not like simple that we can pack it in a cotton. And no, there's like they're shifting a whole uh, what like submarine engine from one place to another, mostly from the UK to Singapore, and from Singapore for maintenance they bring it here. So all their process, and if some things go wrong, and then the one of the route that they use is sea routes, which is sometime if it's out of the season and they need urgent transport, so they need a system which can tell them before, a year before, that okay, next year you're going to bring that much parts into this continent, so you should start on this route from this date to this date in order to complete all the supplies without any breaks or any disruption. So we are still working on that project, and it's one of the important project for us as well, because it is highly funded, and there are a few universities also involved in this one, including University of Oxford and University of Loughborough, Nottingham. So yeah, there's like a lot of universities are involved to deliver this project, which is purely an AI based project. So yeah, we talked about all these things, and now I will talk about the challenges during implementation of AI or machine learning in industrial scale. So one of the problem which is coming is data quality and availability, because you know the industries that we worked with are quite old. They're like 300 years old companies and industries, and they have data written on hands, on pencils and pens and papers. They don't have digital data, so the quality of the data is not that much accurate. So we need to transform the data, and most of the data is that much old that when you open the book, it's already eaten by ants. So yeah, the data availability and quality is very important challenge which you will face during industrial research or industrial development. High computational requirements, because these industries, their data is massive and massive amount, in different, in multimodal, multi-structure, multi-dimensional, multinatural data. So in order to process all of these data, we need a lot of high computational power. Though we have a lot of quantum servers and quite fast servers in here, but still it takes hours and hours to process the data. Integration and existing system, which is you need to integrate it with the existing system. So you're building a new technology, a system or a project or based on a new technology, but you want to integrate it with the old system. It's quite challenging. So yeah, it's one of the most challenges that currently I am facing in, because the pictures or the videos that has been taken on very old cameras, we don't provide much of the metadata with their data, so with the pictures and videos and stuff. So yeah, it's very hard. The fourth problem is black box in nature. Most of the deep learning algorithms are black box. They take input, they give you output, but you really can't say that why did it give me this result. If it's good, you don't know why it's good. If it's bad, well, you don't know why it's bad. You just only can tune the hyperparameters and see how it goes. But yeah, so this research is currently very active among, and we have a few PhDs on explainable AI. So or now we are moving towards explanation so that they can explain why the algorithm gives this result. So yeah, that's need for skilled workforce. What I would say that we have a lot of developers, but we don't have research and developers. So that's why currently we need skilled workforce. A lot of people are needed in AI. Currently, I would say across the Europe and especially UK, I know that we're in need of a lot of AI developers or AI research scientists. And then the last is ethical consideration. So because UK, we have a lot of GDPR issues regards data and everything. So ethical consideration sometimes, especially on medical domain, it's very hard to get data. So any researchers or scientists that work on medical data analysis or genomical data analysis, they are quite um, yeah, like it's a lazy process to get approvals and all these stuff. So you need to consider ethical approvals before you jump into any project. Uh, the last question: are we prepared for this all industrial research? So if you are prepared, these are the few things. If you have them, it means you're prepared. If you don't have them, it means you're not prepared, and you need to do that things to get prepared for the revolution of AI in industrial scale. So mixed level of preparedness across the industries. So preparedness is actually like, are you have people from mixed level in from mixed industries? Because I work in oil and gas, so I'm a computer scientist, but I work with mechanical engineers and fluid dynamic peoples, and people across other backgrounds. So they don't know anything about computer or AI, and I don't know anything about their manufacturing process. So we need to learn and prepare a mixed approach of a person who's a good engineer and who's a good researcher in AI. So it could be a good fit. So we need that mixed level of researchers. We need investment in infrastructure and talent. AI is expensive. So if you want to work on that, you need to be ready, or you need to get investments in this in your projects, because AI projects are not easy or not cheaper to get. So yeah, you need a lot of investments in that. If you have a lot of investments, it's mean you're ready. Uh, Regularity and ethical consideration. If you have all of these things covered, or if you're not, you need to cover them. Policies and governance. So currently, people are working in AI. Whatever they want, they can make it, because there is no control on that. But if you want to jump into an industrial scale, you need to consider the policies and governance around the approach that you're using. So that's one of the thing that key thing that you need to consider about what are the policies in your clients. So you're preparing an AI based project for a client, so you need to consider their policies as well, and then prepare for future generation. So in future generation, we want to have our generation to be used to get with the AI. For that one, we need to have start early computing institution, colleges, and in universities, which I would say even in the current time, our approach of education, especially in computer science, is quite old school. While the research in computer science is getting very faster, so you need to consider that one as well, to start to upgrade your courses, your curriculum, include new courses in that, and then modernize your education strategies to get prepared for the future of AI in industries. And these are the steps to get prepared for deep learning or AI inside the adoption, which is increased adoption driven by advancement in AI. So we need to continuously learning, because if you just familiarize yourself with a single algorithm, maybe tomorrow that algorithm is already passed and you have new approaches, because AI and deep learning is quite fast these days. We have new algorithms and new approaches every single day. So you need to be ready for that, or you need to prepare advancements in the AI to learn about the advancement in AI. Potential for innovation in new applications. So it's like the AI application can be anywhere. It's like we discussed, it's from manufacturing towards the maintenance, and then from even from the medical sciences perspective. Currently, one of the project which I gone through was to design the medical equipments. So their materials, so material sciences are trying to use AI to propose new materials, which is best fit in that sense. Invest in the data infrastructure. So like to getting data is expensive. Data is expensive. So you should have a lot of data. And then upskill workforce in AI and machine learning to train your employees, to your developers, your researcher in AI and machine learning, to give them courses, to give them all the it's like hands-on practices. So you need to upskill them for day-to-day growth of the AI and machine learning approaches in industries. Partnership with AI expert and institution. So currently what happens is in the UK and in the whole Europe and in the globe, around the globe, industries like Amazon and it's like all these Rolls-Royce and JCBs and National Gas, they're investing money in universities to provide them solutions or to give them a hand in partnership to solve their problems. So because universities and institutions have researchers and industries have funds, so they use that funds to get their solution done. So that's how we need to give a hand from industries towards institution and from institution towards the industries, and then stay updated to the technological trends and best practices. You need to update yourself or update your whole organization to the future. So like for example, you start a project now and then within your project's going to be delivered in the next 5 years. So the algorithms and the tools and technologies that currently you're using, will they be valid after 5 years or not? So you need to update yourself with the new trends. Yeah, that's all from me. Thank you so much. I wish I could complete this all within short time, but it took more than that. But yeah, again, thank you so much for listening to me and having this conversation. I wish I would have this conversation live next time, but because of the time constraint and things, I couldn't be live. Couldn't meet you people in live, but yeah, that's it's a great to see you all. If you have any question regards any projects, because I couldn't disclose most of the things because of the confidentiality things, but you can reach me out. I have my email in the SCDM conference, and you can reach me out and we can talk through this one-to-one as well. Again, thank you so much, and
organizations. This opening ceremony is approaching to the end. I am Dr. Fidaus. On behalf of the organizing committee, with a lot of gratitude, I would like to thank our distinguished guests, participants, and delegations, and to every one of you for making time here virtually from your busy schedules. We wish you a productive and fruitful sessions during these 2 days of conference. Please enjoy the rest of the afternoon sessions. Stay safe and have a good day. Don't forget to fill in the registration form available in the chat area so that we can prepare you the certificate of participation later on. All participants and all chairperson for every sessions, please be aware of the schedule and the exact link provided at the SCDM website. You can also access the link by the QR code provided by the organizer. Once again, thank you very much and have a wonderful day. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Good afternoon, Mr. Rizwan Effendi. I believe you entered the wrong session because this is session A.
Oh, sorry.
think-
This is session A.
Yes,
Okay.
maybe you can move to the session B and begin with your presentation. Good luck.
Okay, thank you.
Good afternoon. Yup, you hear me?
Yes, Miss, I can hear you.
Okay, thank you.
Thank you. SCDM online conference. May I take a moment to remind everyone to fill in the attendance form. Can anyone hear me?
Yes, we can.
Okay, a few thumbs up I saw. All right. My name is Yap Liu, and I am the chairperson of this session, session 1A. So I prefer to call it session A1 so that I know all the presenters will be giving the A1 performance. So now, may I take a few moments to remind everybody a few things. The first one is that this is an online conference and it is a formal conference. So I really encourage everybody to kindly turn on your webcam if you are presenting, and then you might present live and not the recorded video, because the recorded video is actually for like a backup if the connection is not so smooth. So I encourage everybody to turn on the camera if you can. Secondly is regarding the attendance. So if you haven't already done so, please do so. Thank you. For now, our session will begin with the first presenter, paper IT 038. And the title will be Comparative Assessment of Facial Expression Recognition Models for Unraveling Emotional Signals with Convolutional Neural Networks. However, I believe that the presenters are not yet ready in this session. Therefore, I would like to remind everybody to be on time, and also the next presenters, which are Deshinta Arova Dewi, Tri Basuki, Kurniawan, Muhammad Zaki Zakaria, Dr. Sharin, Nur Kashi Mustafa for the paper of sentiment analysis on Umrah packages reviews in Malaysia. Kindly get ready in case you have to present earlier. So now I believe,
noted.
all right, thank you. So now I believe we shall take a few moments just to confirm whether the first slot will be attending this conference. Thank you. That the first presentation for the first paper is not able to make it. So we shall proceed to the second paper, which entitled Sentiment Analysis on Umrah Packages Reviews in Malaysia. May I know whether the authors or the presenters, Deshinta, are you ready?
Yes, I'm here. Give me 1 second to share my slide and on my camera. Thank you.
Okay, no problem. Thank you. So while you are setting up, I want to remind everybody that the presentation shall be allocated for 20 minutes. It means it includes your presentation as long as the Q&A session. So please strictly adhere to the time limit and all the best to your presentation. Thank you.
Okay, thank you. May I know whether I'm audible and you can see the slides?
Yes, we can see and we can hear you.
Okay, that's great. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to everyone. So my name is Desita Rufadewi. I'm the presenter for sent to this conference. The title is Sentiment Analysis of Umrah Packages Review in Malaysia. The outline of the presentation today, I just conclude as four section of it. So the first one is the introduction, and then the methodology, the results and analysis, and also the conclusion. As the introduction, we are motivated to have this kind of analysis and also research is because we have seen and read several information which is in the popular websites and also newspapers that until now 2024 there are still individuals suffer over losses due to Umrah scam in Malaysia. In fact, in 2023, the Police Malaysia has confirmed they have received 399 allegations about suspected Umrah package scam by local company in Malaysia. So when we talk about 399 allegation, so this report include 1,614 pilgrims around the country, and then the approximately of loss is about 14 million ringgit Malaysia. Of course, our research may not be what you call as great to contribute to this occasion that happened in Malaysia. However, we believe that by starting something about the research in this area may bring certain awareness and also carefulness in choosing the services of Umrah. We have decided to use social media as the source of the data is because nowadays individuals are more comfortable sharing their ideas, opinions, and also themes on social media, including experience with the fraud of the Umrah packages. And we just performed a classification study from these resources that developed the sentiment analysis against the available Umrah packages. So the methodology we use for the text analysis, we start with the register names, and after that several entries in the websites and also social medias, and then we process the text, and we split after we do feature extraction, then we split the data into for the training data and also for the prediction of the whether in the future they can assess, they can identify whether this one is categorized as the what do you call Umrah, whether it is scam or non-scam. With the output, it is true, false, and also true. The sentiment analysis somehow plays crucial role in understanding public opinion and also social media trend, and also it involve analyzing the emotional tone and polarity of the given text. Below are the small example of the dataset. Some of the dataset that we use are actually in
Sorry to interrupt.
Yes.
Sorry, because somebody raised your hand. Sorry, Nur Aida binti Husaini has raised a hand. May I know if you
Okay.
have something to say? Or you might want
Sorry,
to...
because I think the presenter not projecting the right screen.
Oh,
Really?
Maybe you can. You,
I
think
actually can
Ah.
see, but maybe
okay, then I do in this way. Is it showing?
it's showing data processing now.
Yes.
I think
Okay,
it's
what I do now, yeah, I feel it's fine too. What I do now, I just use this screen. I believe most of you can look at the screen correctly, right? I'm now at the methodology slide number 5.
you are methodology, right? I can see it.
Yes. Okay.
Oh, okay. Can you try to zoom in a bit bigger, like enter the presentation mode?
Actually, I was entering the presentation. What about this
But
one?
I can't really. Oh, actually, we see you are in the editing mode. Maybe that's the problem. Is it no Aida
Okay.
bit? Do you mean
Okay.
this?
Let
Yeah.
me just stop
Ah,
presenting and
okay.
then I will share it again.
Yes.
Okay. I will just do the entire screen. Okay. Are you able to see now? And let me try to zoom it in one more time. Are you able to see now?
Ah, yes. Okay.
Okay, that's
Yes,
great.
this
So
is
it
better.
should be,
Thank you.
yeah, okay. All right, welcome. So basically, as I mentioned, the methodology we are using text processing. So the text that we got from the social media, then we process the text analysis using the algorithms. Then after that, we do feature extraction. Then after that, we split the text into two set, which is one for the training and another one for the testing and making prediction. This is the example of the test that we analyze. It involved the emotional tone and polarity of given text. And here are those small examples of the test set used in the study. We have compilation of the Bahasa Malaysia in English. So for those who are in Bahasa Malaysia, we translate into English using just very simple translation using Google Translate. In terms of data processing, we follow all the data processing for the text analysis. So the first one, we do the lowercase. So all the text that has come to the machine, we do lowercasing it. Then after that, we remove the punctuation for this process. Then after that, we remove also the stop word. Also, we remove all the numberings, the one that we feel is not contribute to the data, to the analysis. We remove it. Then after that, we do tokenization. We try to extract the what you call the text, yeah, the original text of the English for the analysis. Then after that, after we tokenize, then after that we do the stemming. Then after that we do lemmatizer. So after we do lemmatizer, you can see all this is all the column that we have cleaned up the data. Then we have come up with the clean data. So this is basically the data processing. Then after that, we do feature extraction, we do TF-IDF. This is only examples. Basically, if we use TF-IDF, means that all the text that we have got it, then after that we calculate the TF and also to calculate the ADF, term frequency and also the IDF of it. So by using the TF-IDF, the machine makes sense of the important words in a document and important words throughout all the document. So the way we do is that one data, we do the analysis. So for example, in this year we have 10,000 data, then we do 10,000 analysis towards the text. And after that, only we do the training and the testing, the training process. Then after that, we have the models. So after we have the models, then we run again over the remaining data. 70% for the training and 30% for the testing, and we use the model classification model to run the testing. We selected the three algorithm in this view. So the first one is the knife base and also support vector machine and also random forest classifier. So we just straightforward in this view. Knife base we select is because that's the basic algorithm in the text analysis. Then the random forest basically is because our text is a review text, so it's not short sentence, so it is like long sentences. So that's why we consider random forest classifier and also a support vector machine. The result, we run Gaussian and multinomial knife base, and this is the precision, which is 91%, the recall, the advanced score, and also accuracy. So in this view, the support vector machine basically run better. It's because we are using long sentence in the text. If we use a short sentence, then usually random forest will perform better. And this is the visualization of the accuracy of all classifier. So by having this, basically the initiative is actually intended for those who intend to perform the Umrah in the future. And also the data come from the social media, which is quite straightforward. Then after that, the classifier demonstrate the polarity. We use polarity. We don't use context tool a lexicon-based analysis. We don't apply that. We just apply from the data that we get from the social media. Then after that, make a recommendation to highlight the area for the future performance, which one to enhance and also to improve for the number of data sets. And perhaps this research project could help people in choosing a decision regarding umrah package and agency they should choose before purchasing them. With that, I conclude my presentation.
Thank you for your wonderful presentation. Now I shall introduce, now I shall invite everybody for a discussion about the Shinta's presentation. Perhaps you have some questions that you might want to ask regarding the research. Since we still have roughly 10 minutes since the Shinta started the presentation, now we have 10 minutes for the Q&A. I do encourage everybody to raise some voice to let us know what you think and what you want to find out more about the research, maybe some details. Anyone? So if you have any questions, you may type it in the chat room so that I can help to read it out for you to avoid confusion. Maybe your mic cannot be heard or something. Don't be shy, please. I am waiting for some questions. In the meantime, I want to congratulate Deshinta for being able to complete this research paper. So may I know that is there any like challenges regarding maybe technical challenges you faced during the research? You mind sharing?
Much. Basically, the challenges as usual. Actually, this is the project that I did with students, and we try to see text analysis more. So we have several what you call data, and text seems to be quite interesting to look at. So the challenge that we have is basically to extract the data from the social media. We do web scraping, we do blogs. So not only on the Facebook, Instagram, TikTok. TikTok is and also what they call Twitter, yeah, and also blog. So we cover all the five. So basically, when we do data scraping, we try to develop RPA, the robot processing of automation. However, it fail certain times. So we have to rewrite the RPA many times until we get 10,000 data out of across the 5 social media platform. The second one is also the language that we encounter, which is a combination of language, sometimes project language when people put into social media. So our machine basically having difficulties to train to understand between English and Malay. So that's why we decided to translate all the non-English words into English so that the machine can have roughly what they call understanding. And then another challenge is to balance the data. Balance data in the sense that whether the data learn about Umrah scam more. I mean, the data we cannot control because it's come from the social media. So balancing data set is another one. So we decided to put it like approximately 30% neutral one, 30%, and a positive negative also 30% with little bit somewhere in between. So actually the data that we're able to scraping is 25,000. However, due to many noises, errors, and all, so we can clean up the data up to 10,000. So this is actually the result of the 10,000. Yeah, basically that's what I can share.
The result is actually quite huge, 10,000.
Yeah,
see.
the result is quite, it's 10,000 10,000 review. So
Wow, I
10,000
see.
review we scrapped, and then one by one we do.
Like
all
one
the
by one.
process.
Wow.
Yeah.
What a marvelous work. I also heard since in the chat room there is not yet I received any other questions, but I do have one more question I want to ask because
Okay, sure.
just now you mentioned about RPA, which I know RPA is robotic process automation. Right.
Correct.
I see. Do you like have any specific like tools or
Tools, yes.
software?
Yes, we have
I see.
specific tools. We tried 3 specific tools. I cannot remember all the names. I asked the students to do that.
Understood.
Yeah.
Wow.
Because once we run the algorithm, we do web scraping.
Hmm.
We don't want to do download one by one. So what we do, because it is like, uh, we uh, we we write script so that the script will go to the certain websites. For example, the script will open TikTok website, for example, or will open Facebook website. Then specific website, we ask the robot to go. Then after that, run, for examples, until how many pages? 20 or 25 pages, meaning that 25 scrolling down there. Then after that, the data will be saved into one folder. So it's not student the one who doing it, but AI tool the one who do it. And then we can run it like, anytime we can do something else. So let robot doing it. And then one script we do for TikTok, one script we do for Facebook, one script we do for Blogger. So that's the reason. Because robot the one who doing it, so all the things that talking about umroh, talking about the what do you call the name of the agent. So we got all the data. So basically, until we do until 60 folders that we can scrap for 1 week. So no need to do human work. We just do AI the one who will do that, to do the data gathering. Yeah.
That's really good because living in this era, we must know how to use the tool. So
Correct. Yeah.
very, very good job done. Well done.
Okay. Thank
So
you.
now, thank you, Deshinta, for your wonderful presentation, and congratulations for publishing in the full name is LNNS Spring Journal. Thank you.
Thank you for the opportunity. Thank you.
All right. So now I shall proceed with the next presentation. Supposedly, it's supposedly the next presentation will be done by Muhammad Safwan, but since I just received the message that the team is unable to present due to certain reason, that's why I would like to have the technical team to play the pre-recorded video, which is in this situation a very helpful act for the presenter, because I believe all the presenters should pre-record the video as a backup. So in no further ado, please let me handle the technical stuff for a while.
Hello. Let me share my screen.
Hi.
Okay. Assalamualaikum and good afternoon. I greet to all our respective. Today I will present my conference paper on spiking neural network for microseismic event detection using distributed acoustic sensor data. So before I proceed with my presentations, let me introduce myself. My name is Muhammad Safwan, and another two is Nur Farisha bin Muhammad Krishnan and Farahida Hamnim bin Di Mansur. Next. So we begin with the overview of what is a microseismic. So microseismic is involve the identifications and analyze the small seismic event detection which cannot be seen by the human hands, and which they provide the crucial insights into a dynamic process occur, such as a movement of the fluids and then the behavior of the formation rocks. And then what is a distributed acoustic sensing data? And what is the tools? The tools is a distributed acoustic sensing. So it was being installed in the target reservoir, and then actually this is a 1N cables that use the 1,000 pulse of the light along the fiber in a second, and the vibrations surrounding the environment will disturb the backscatter at the one point in the fiber and will be generated and be observed by the dust integrator. So the acoustic sensing is along the entire fiber. And then compared to the geophone, it's very effective and continuous monitoring of the reservoir. Next. So the challenges in the microseismic detections is actually the previous one is using the manual picking is very time consuming, and then the second one is the data is very huge. We collect the data is terabyte of the seismic data daily, which exceed our storage and capacities and analysis capabilities. So machine learning actually helps to improve the signal processing and accurate events detection in the dust data, enabling the better understandings complex acoustic information. So we use the spiking neural network for microseismic event detection on the dust data. So this is the examples of the manually picking events. So the image represent the microseismic data showing the seismic trace from the small scale of seismic event recorded by the dust and the curved linear, as you can see in this image. The patterns indicate the arrival of the seismic wave from the microseismic event with the color scales reflecting the amplitude of these signals. Next. So this actually the secondary data collected from the FOCH, and where the fiber optic cables is installed 1 kilometer deep into the monitoring wells, and then it's very successfully detected 40 microseismic event over 11 days. And then the total size is 13 terabytes, is very huge. So to enhance our analysis, we also generate 7,000 synthetic microseismic event, and additionally, the noise was introduced at the random times and channels to stimulate the realistic of conditions. Okay, next. So now we talk about the machine learning stuff. We designed the analysis of our data sets. We divided our data into 3 main categories, which is training, validation, and testings for both microseismic and noise event. We allocated 6,000 event for training and 5,500 for validation and testing. So this brings a total of 12,000 event for training and 1,000 each for validation and testing. So to process this data, we converted into seismogram into a gray scales image with the resolution of 266 by 266 pixels into our network, neural network. Next. So for the data pre-processing, we start with the data collection, and then where the data set is combined from the UTAH, like I said before, and then the next step is to solve or figure out the current problems with the DOS application. For example, the fast data, and then the noise data, missing data, and then the delays of the data preprocessing lah. So and then for the model architecture where we choose SNN, we divided like I said before also 7:3 ratio, and then the cross validation techniques to optimize the choose the most suitable hyperparameter, and then to optimize and customize the machine learning techniques. There's a 4 components here, which is a active patient function, training algorithm, number of neuron, and number of layers. So the activity function, like we use adaptive exponential integrate and fire models, introduce the crucial non-linearity, enabling neural networks to learn the adapt to the various tasks. So for the training algorithm, also we use the STDP, which is spiking timing independent plasticity, which is to improve the weight based on the errors, driving networks towards the better prediction. And then the number of neurons, the hidden layers determine the complexity of the layers, and then the numbers of the layers also in the network correlated to the depth understanding. So next. So for the proposed approach as an architecture, we first process the raw data signals into our microseismic event detection process. This involves the extracting the relevant features and we use the encode scheme like rate base for these transformations. Once encoded, these spiking trains are processed by the spiking neuron, and then this neuron integrate the spike inputs over the times and triggering the spike events based on the specific dynamics. So we emphasize the temporal processing utilizing the refractions periods and effection temporal encodings to the capture temporal dependencies effectively. So finally we to the output layer, we integrate the spiking activities, specify the presence and absence of the microseismic event and also noise event. So next. So based on this result, we discuss the performance metric of the spiking neural network comparison between SNN and CNN for both training and testing. In this training phase, we can see that SNN is outperforms of CNN across the metric, including the accuracy, recall, precision, and F-score. So SNN achieved like above about 80%, while the CNN is lagging slightly behind. And then this training continues to the test phase also, where SNN is not only maintained but slightly improved its performance, reaching like over 80%, 81%. Meanwhile, the CNN showed a slight drops performance during the test, highlighting this superior stability and generalization of SNN. So next. So SNN actually is outperforming the CNN in terms of accuracy, but in this case, the time course like CNN is take twice, double from what CNN, and then which competes like 0.2 seconds. for CNN. So this disparity highlight the trade-off of between SNN superior performance, but it's a slow processing time. May the factors to consider when applying these models in real time resource the constrained environments. Next. So in the conclusion of discussion, let we discuss about the comparative strengths and limitation of SNN and CNN. So the SNN stand out abilities of complex, capturing the complex patterns of temporal patterns. So making it highly effective in providing or more insightful insights from the data. It's a event-driven nature. Also, the contribute to the enhance the energy efficiency. But however, it cost or increase the computation times, as we've seen in the cost time analysis. So on the other hand, CNN is offer the more conventional approach lah, with the faster computations, which can be beneficial in time-sensitive ratio lah. However, I think its ability to extract the temporal dynamics is less effective compared to SNN, potentially the limiting its accuracy and interpretability in a task requiring the detailed temporal analysis. So ultimately, on the choice of SNN and CNN depends on the requirements of applications, whether it's priority to the speed or the depth or accuracy temporal pattern recognitions. So next. So I would like to thanks to Total Energy give a grant for this project and with the help of the University Technology Petronas. So thank you.
All right, thank you. Since the presentation just now is actually not live, but pre-recorded video, therefore, I will encourage everybody, if you will still have any questions regarding the research, you can write in the chat room so that I can have the committee to give the question to them. You might get your answer in the future. But for now, due to the time constraint, I might proceed to the next presenter. So I believe I already stated in the chat room. If you notice that, presenter Pei Jing Go, Mei Hao Hu, Ko Ching Ko, for the paper entitled Evaluating Deep Transfer Learning Models for Detecting Various Face Mask Fairings.
Miss
I
Yap,
know.
can you hear me?
Okay, you can hear me. Can you try to share your slide, please? Let's see if it's working.
Sorry, a request because I've been disconnected from the line for many times already. I feel
see.
that the line is really weak. So can you help to play the video for me? I'm really sorry about that.
Oh, I see. It's all right. Let me try to contact the technical team.
Okay, thank you, thank you. Hello, everyone. My name is Kaur. I'm from University Tunku Abdul Rahman. The title of the paper that I'm going to present today is Evaluating Deep Transfer Learning Models for Detecting Various Face Mask Variants. As we all know that wearing a face mask is no longer mandatory in Malaysia to prevent COVID-19, but due to the increasing public awareness of airborne diseases, it has become a customized culture for people in many Asian countries like Malaysia to wear face masks daily. Not wearing face masks in certain Europe countries may be an issue. For instance, in Europe, the Scottish Healthcare Workers Coalition has recently criticized their government for ending universal mask wearing in hospitals, putting medical personnel at risk. Even though COVID-19 is no longer a threat to Malaysia, but wearing face masks may be important in futures if another outbreak occurs. It's really time-consuming and effective to manually determine whether someone is wearing a mask, especially during an outbreak. And having a large enough workforce to be placed in many locations for monitoring is also quite impossible. Besides, wearing a face mask is also important in environments such as clean rooms, operating theaters, and crowded places. So for all these reasons, developing automated system for detecting face mask wearing is very important. So in this study, we contribute to understand the effectiveness of deep learning models for automated face mask detections. In this study, we trained 5 pre-trained deep learning models, evaluated them, and found the best performer for 4 categories of face mask wearing. Number 1, faces without mask. Number 2, faces with a single mask. Number 3, incorrect mask wearing. And number 4, faces with double mask. We used 5 deep learning models in our study. Number 1, BoBoNet V2. Number 2, VGG16. Number 3, ResNet 152. Number 4, Inception V3. And lastly, exceptions. Okay, the reasons that we use deep learning in this study is because deep learning really can provide a very good accuracies when dealing with images. For information, deep learning algorithm can ingest and process images without the need for feature extractions or data preprocessing, like what happened to traditional machine learning algorithms. Deep learning algorithms actually contain many hidden layers. Each hidden layer has an activation functions that can actually be utilized to send information between layers. So the output of this layer can actually be used as the input to calculate the network's final output once all the hidden layer outputs have been produced. Forward propagation is what we call to describe this computation across the network. And deep learning also includes back propagations, which allows the recognitions of errors to be propagated backwards through the layers to enhance recognition's capability by adjusting the weights and also the biases. We use transfer learning for our deep learning models. This is because if we try to train a deep learning models from scratch, then it will need a lot of data, a lot of images, and then training this kind of model can take days or weeks. So using transfer learning, an existing deep learning model that has been pre-trained can actually be retrained using the data set that we have collected to create a new model for a similar task. For informations, existing works use 2 ways to determine whether a face mask is present or absent using deep learning models. So number 1 is to use transfer learning, training an existing CNN like VGG, Inceptions, ResNet, or BoBoNet. Number 2 is to use a CNN backbone and then accommodate it with other objects detections model. So for informations, the recent research works include detecting faces with or without masks, improper mask wearing, detecting occlusions on faces, type of mask, and social distancing. And most of these existing works focus on detecting no mask wearing, single mask wearing, and inappropriate mask wearing, which will be included in our study as well. And for information, the former Director General of Health Malaysia, Tan Sri Dr. Noor Hisham Abdullah, recommended using double face masks in May 2021, citing the potentials for these preventive measures to reduce COVID-19 transmissions by as much as 96.4%. So in this case, we also include detecting faces with double face masks in our study. So we need to collect images for these 4 classes of face mask wearing. Number 1, no mask wearing. Number 2, single mask wearing. Number 3, improper mask wearing. Number 4, double mask wearing. For training our model, validate our model, and of course to test our model as well. So these images were collected from the MM dataset, MAFA dataset, mask FaceNet dataset, and lastly FMD dataset. Okay, now each of these classes contain 500 images, and in total we collected 2,000 images. But because of the scarcity of online double mask images, different search engines were used to collect that. We also try to create artificial made double mask images as well, like what you see in figure 2E. Now, so the first 3 datasets were treated as training and testing set from the same distributions. And then the last dataset, which is the FMD dataset, was actually used as the testing dataset from different distributions. The reason is because the images in this dataset are basically largely from the candid photos, and thus they actually looks more real-like compared to the others. After we get the dataset ready, then we'll proceed to the data pre-processing stage. So all the images will crop into one face per image, and the dataset was then converted from RGB to BGR as OpenCV read images in BGR format. Then these images will resize according to the requirement of the pre-trained models. For instance, we resize those images to resolutions 224 times 224 for the models like MobileNet V2, ResNet 50, ResNet 152, and VGG 16. And then we resize the images to resolutions of 229 times 229 for inception V3 and exceptions. We also perform data augmentations to increase the numbers of the images for training. So this data augmentations technique was actually carried out with 0.1 zoom range, 25% rotation range, 0.1 width strip range, 0.1 height strip range, 0.15 sheared range, and lastly fit horizontally. For the pre-trained models, we froze the pre-trained convolutional base to extract the features from the images. So these layers from the pre-trained models, they were frozen in order to prevent reinitializations the weights in those layers. And then we replaced the top classifier of the pre-trained models with a new one. The reason we do so is because the original classifier for the pre-trained models is actually designed for different numbers of classes based on the ImageNet dataset. If we never replace them, then the model will only classify images to those category of the image dataset. So to replace the top classifier, we did by adding a flattened layers to make the image flat by turning the multi-dimensional array into one-dimensional. And then we added one dense layer with Lulu activations. The reasons we use Lulu activation is because we want to combat the problems of vanishing gradients. And then we add a drop-out layers to avoid overfitting the models. And last, a dense layer with softmax activations was added to the final layer. The reasons that we use the softmax activations is because we are dealing with multiple classes in this study. So the demand for the last layer was set to 4 as only 4 classes of face mask wearing were involved in this study. So the collected 2,000 images were divided into 3 sets. Training, which take 80% of the images, validation 10%, and lastly testing 10%. So initially the models learn and fit the parameters using the training data set. Then the validation set was used to fine-tune the model's hyperparameters to improve their mask detection performance. So the research CV from Python scikit-learn was used to find the optimal hyperparameters for the models. Then the testing set with 200 images from the same distributions as the training set was then used to evaluate the final models. Now to further evaluate the robustness of the model, we also use 2 other testing data sets that come from other distributions. Number 1, 120 images from the FMD data set. So they will serve as the images from the different distributions. And number 2, 12 real-life videos captured using a smartphone. So in this slide, we give examples of the images that come from the test data, which is actually coming from the other distributions. So the top row shows the samples of 120 static images from the FMD dataset. And then the middle row shows the sample images that captures from the frames of the video in the last row. Come to the result sections. So as mentioned before, we use Research CV for optimize the 5 learning models. And the hyperparameters that involve were learning rate and dropout rate, and these are their optimized value. And for information, all the models use Adam as the optimizers. And these are their test score for validations. And according to table 1, ResNet 152 actually performed the best compared to the others. So this is the testing result. So for informations, we use 3 test sets for testing the robustness of the 5 training models. So the first test set is actually 200 images from the same distributions. And then the second test set actually contained 120 images from the FMD dataset. And we also have 12 videos that we captures using the smartphone. And for information, ResNet 152 performed well with an accuracy of 0.83, 0.8667, 0.8447 for the test set from the same distributions as the training set, the test set from the other distributions, as well as the video frames respectively. So the second best model is inception V3, then followed by exceptions. For information, the MobileNet V2 has the shortest testing time, but its accuracies are low. To conclude, out of these 5 deep learning models, ResNet 152 is actually the best. And there are a few things that we observe from our experiment. So firstly, if we gather the image data from an individual from a far to a close distance, I mean in the video frames, then deep learning models will fluctuate in detecting the mask. And we also observe that detecting double mask in video frames is really difficult. All these deep learning models perform weakly with a recall rate of less than 30%. Even though these weak performance results, they are not tabulated in this paper, but you can observe it from the overall accuracies of these deep learning models. And all these deep learning models achieve an accuracy of less than 90%. The reasons that detecting double mask is really difficult is because the model always identifies the double mask as single mask when an individual is actually far from the lens. Another reason is because of the lack of real life data for double mask varying when we do the training of the deep learning models. So now to solve the problem that we mentioned just now, fluctuations of detecting the mask, then we actually recommend using a better camera or gathering more data sets and then use them to train the models. So the real-world shootings can actually be carried out to collect more realistic data for double mask wearing. We also recommended to use the two-stage object detectors and one-stage object detectors to see that whether improvement in detecting face mask can actually be done. This is our reference list. Thank you very much for listening to my presentations. I really appreciate it.
Thank you, technical team, for playing the presentation video. Now we might proceed with the next presentation. But before we do so, let me remind everybody that it is very highly super encouraged that we present live instead of playing the pre-recorded video, because by doing your presentation live, you'll be receiving a set of participation. So it's highly recommended. Now we might have to is Shariza Salih, Roslina Zarima Zakaria, Siti Roslinda Yaziz. Are you ready for the next presentation?
Yes, I
Because
am.
we might have to start with your presentation. So please kindly check whether your mic and your share screen function is all working well. All right.
Is everything looks good from your end?
Yes, we can see.
Okay.
Perhaps you have to try entering the
Presentation mode, yeah?
yes. Can you
Okay.
try to scroll up and down? Because just now, this function is not happening with one of the presenter. Can you like move to the next slide? Okay.
Does it work?
Yeah, it works. All right.
Right.
So you may begin your presentation or the best, and you have 20 minutes, including your Q&A session. Thank you. Good luck.
Thank you. Thank you very much. Good afternoon. Assalamualaikum, everybody. I'm Sharizal, the presenter for today. I'm a PhD student from Center of Mathematical Sciences, University of Malaysia Pahang, Sultan Abdullah in Kuantan, Pahang. Today I'm going to present a paper titled Battery Electric Vehicle Charging Load Forecasting using LSTM on STL trend seasonality and residual decomposition. Okay, just a little bit of introduction with all the hype about electric vehicle, a lot of Teslas, a lot of BYDs that you can see on the road nowadays. It actually started with a few initiatives by the United Nations to have all the countries agree to reduce the emission of national greenhouse gas, harmful GSG. One of them is carbon dioxide. The reason why carbon dioxide is the indicator is because about 60% of composition of GSG is carbon dioxide. So they use it as a measure. So according to YE, about 1/4 of global emission comes from internal combustion engine vehicle, ICE. Yeah? So one of the driving factor to reduce CO2, to reduce the CO2 generated by the emission from ICE vehicle, they go to battery electric vehicle, which battery electric vehicle doesn't have anything else to power it except for the electric chargers inside the battery on board. So because the size of the battery is so big, then most of the time you need to be connected to the electric grid. So right now is maybe not so big thing, not really a big issue, especially Malaysia, because I heard from my friend in TNB, we are running at 50% capacity. So if any spike of like 5% or 10% from BEV, there are a lot of time to improve their infrastructure. But there are countries that are actually running at 99% or 100% capacity. So a small bump in the demand, electricity demand from BEV is going to cause some electricity issues, right? So according to Dr. E in 2022, he said that the load, global load from global electricity demand from the EV will be going to be around 670 gigawatts. So that's a big factor. And also, there's another interesting thing. A lot of paper that I read, they only focus on the public charging networks. So these public charging networks are the charging stations that you can see at the gas stations, that you can see at some rest area along the highways. But those are not really a big issue because it's well-known location, the electricity already like pre-design and everything, and there's a limit, a number of car that can be charged at one time, but that only cover about 8% of total BEV chargers according to Chang in 2021. But majority of the chargers are actually the home charger, right? The private chargers. So the reason why probably not many papers written on the private chargers, mainly because of lack of data. Okay, so for this one, I'm more inclined to go towards the to research on the private chargers, and well, luckily I managed to source a secondary data from my Electric Avenue program, which in this program was initiated in 2013 in the UK, which about 300 units of Nissan Leaf was lease or loan. I'm not sure how the thing works, but in the end, the data was collected by these by the sponsors, which was I think EA something. Okay, so one of the interesting data that I managed to scrap from the program was the discrete start and stop charging data. And well, by itself, it's not really usable to predict the electric charge demand from the vehicle, right? So there must be some feature engineering that need to be done. So you can see here on the left is a start charging event. If it's in a raw form, on the left is start charging event, the right is a stop charging event. You can imagine this as a time to indicate. Unlike if you're in your kitchen or in your bathroom, right? You have a tap, so you turn on and you turn off. So the data only indicate when you turn on and when you turn off. But when you turn on the tap, actually water flowing through. Same in here, the start time is actually when the charging starts happening. But along the way from the start to the end, electric charges flow through. So as long as electric charges flow through, there's a consumption from the electric grid. So what the data that you can see in here, you can see spikes, and maybe eventually on this snapshot date that I select on this one particular day, there are two events that two cars are being has start charging at the same minute, at the same time, right? The interval of this is in minutes. So the feature engineering that I have to do is I have to record the start and stop date, and then along the time for every minute that the car hasn't stopped charging, I record it being actively charged, and then I count all the cars that still charging, right? So the here on the left is the count number of cars, but since it's a Nissan Leaf, it's a uniform brand, so it's consume the same number of power for each car. So this can be calculated and into kilowatt if you need, but I'm not going into that. That will increase the processing power, use of processing power. So just leave it in integer. It will use less processing power. All right. So okay. So now I already have this, from now on, this will be called observed data, right? Although it's feature engineered, but I'll just call it observed data. And some interesting thing that you can see in here is this is duration of 1 day. And you can see there's a seasonality. That means there's a daily seasonality, which people start charging around 6 p.m. There are a few factors that leads to this. One of them is probably there are some tariff in the UK that encourage people to consume electricity at night. And also at the same time, people come back from work, maybe arrive around 6 p.m. and then they start charging. So you can see the spike in here. And also at the same time, you can see much coarser patterns here, seasonality patterns here. Those are the weekly seasonality. So you can see that this data have two seasonality. And one of the things to simplify or maybe to improve, at the beginning, I was thinking that maybe if I can separate all this information into its own components, probably you can improve the overall accuracy of the forecasting, right? So what objective of this paper is to forecast future consumption, the next step, future consumption. So one of the method to do decomposition is using seasonal trend decomposition using loss, which was initially introduced by Cleveland RB in 1990. Okay, so what's important here is just like encryption in certain technology, right? If you want to encrypt, you need to be able to decrypt back to get back your original data. So I start with this. So it is true. I already checked and verified that once we decompose into its trend, seasonality, and residual, we can reconstruct it back into the observed data. Okay, so this is an explanation about STL, but what it does in short is there are two filters. One is the low pass filter. So what low pass filter does is it remove all the high frequency activities from the data, and then there's another filter that record the predetermined period of the frequency, right, that you have already predetermined from looking at your data. And then what's not in those two is considered as residual. So back to this equation. So observed data minus with the minus T and S, that become the residual. So that's why you can convert it back. So these are the outcome of the decomposition. I managed to get a trend, seasonality. For in this case, I decompose into daily seasonality. So you can clearly see the weekly seasonality in this data, and then the rest are residual. Okay, so for forecasting, I use LSTM. Well, this is a representation of LSTM as far as I can understand, the original method, original paper. So these are the architecture that I use. I put all 125 units of LSTM cell into a single layer, and then the data was divided into a sequence of 60 data points. And this image is just simplified using 4 cells, but in reality, in my work, I use 125 units of LSTM cells in a single layer. Okay, so for this work, I use supervised learning. So that means for 80%, the window of training is 80% of the earlier data sets, and then we try to forecast the remaining 20%, and we use the next 20% as training data sets. And number of data that I've transform this from the original one. It was about 500,000 data points, and divided into training and testing, which 452,304 data points for training and 50,256 data points for testing. And to check accuracy and everything, I use MAPE and RMSE, but personally I like MAPE best because with MAPE you don't need to worry about the other people's work, the unit that other people's work was using. So if other people using kilowatt, other people using megawatt, what I need to know is what is the percentage error. But there are some issues with MAPE that you can see there are sometimes the value is too big because of the denominator. So in my case, I don't really encounter that, so I'm comfortable to use MAPE. Okay, so these are the results. Okay, so for this work, I use selective epoch from one epoch. Epoch means number of iterations for the training, right? So one epoch means just one time, one cycle of training, and 10 epochs, 10 times a cycle of training. That means the cell is improved over the previous results and up to 50 epoch. Okay, and then I use the decompose trend, seasonality, and residual, and these are the loss function of the work. So you see that with one epoch the loss function is still high, and then eventually by 10 epochs it's already like considerably quite low, and then by 20 I think it's quite good already. It's not that far off from 50 epoch, so I think by taking it from 20 and onwards might be good because it saves the training time. And overall results, okay, there are combinations, right? So when you combine the result of the forecast from trend, seasonality, and residual, there are 3 to the power of 3 combinations. So from the number of combinations, I pick top 10s. Okay, so the trend of the best was MAPE with 1.21%, with combination of trend was ran at 10 epochs, seasonal at 30, and residual at 40. And compared to running LSTM just on the observed data alone, this decomposition technique improved the accuracy by a little bit, which I think is good because from this result we can further investigate how we can improve further using this STL decomposition. And in the conclusion, the STL LSTM method proposed in the study achieve a slightly lower MAPE and RMSE value compared to the baseline forecast using observed data. That's one achievement. And also another thing, this method, this network can be used for utility energy companies for the USTLF, ultra short term load forecasting, which usually range from few minutes to hours, because with this data we can show that the LSTM can perform, can model and perform forecasting accurately on a very small resolution up to 1 minute. Okay. And the approach demonstrated by LSTM network in predicting the EV charging behavior can be extrapolated to focus on USTMF, which is important for facilitating rational tariff adjustments, smooth system operation, and enhancing economic efficiency. As an acknowledgement, this research was funded by UNPSA with the grant number and the special publication grant from Research and Innovation Department. So thank you very much for the opportunity. Look forward to constructive Q&A.
Thank you so much for your wonderful presentation, Shariza Salih. Now, let's open the Q&A session. If you have any questions, kindly write it down in the chat room so that I can read it out for you. Anyone, please don't be shy because we expect to have a very fruitful discussion among the presenters and all the participants. So if you have anything that cross your minds regarding his research, about the battery electric vehicle? Please write the question in the in the chat room area. We have actually 3 minutes for the Q&A. So I think while waiting for the question, let me generate one question first. Actually, I am quite what do you say? Quite interested in this EV charging load. But may I know that the charging also works with any kind of EV vehicles, or it's like you have some restriction? It's for which type of EV and so on, or it's like generally for any type of EV?
Okay,
Okay, thank
understood.
you.
Okay, sure. Thank you for the question. Okay, so there are few achievements that I've done with this paper, with this research. One of them is to make use of this, because the start and stop charging event is actually a normal method to record by like the EV manufacturers to record the consumption or well, charging consumption or battery health and all those things. But the data that they use, that they collect, usually are just start and stop charging. So one thing that I've developed for this work was to convert that into, these are discrete data, right? So it's not really useful for time series analysis, but if you want to do time series analysis with the Box Jenkins, with Sarima, with LSTM, because LSTM is method that it remember sequence of events. So if you want to do prediction of sequence of events, say like in the maybe last 5 years before ChatGPT, for Gemini was a big hit, one of the things that people use LSTM was actually to predict what is the next word that people are going to type on the Google search engine. So if you remember like 5-10 years back, it was a big thing, because that's the power of LSTM. It can remember the sequence, and then it can do forecasting for that. So for that, LSTM is good for time series analysis. So if I want to use LSTM, I need to convert from this format into this format. So back to your question, it's a bit easier with this data, because all the all the data are recorded under Nissan Leaf, right? Right. So this the program actually loan out about 300 units of Nissan Leaf. So what you can do from here is just multiply this number of concurrent events with the amount of power that that Nissan Leaf consume, right? But if like in real world scenario where you have Tesla, you have BYD, you have maybe coming soon Proton are coming out with their E whatever, Pro also coming out with their E whatever. So it's going to be a bit challenging, because the power, unlike although you can do similar study like this, but the multiplication factor is not the same. Like this, 20 concurrent charging event means 20 times whatever power that being consumed by Nissan Leaf, and then that is the power that that demanded from the national grid. But if the composition is different, then need to separate each one of the model and make into separate basket, and then analyze each one of them individually, and then combine the amount of power afterwards. So that's how I take it as it is. But again, back to your question, as long as a battery electric vehicle, which to propel the car forward, move the car forward, it requires power from the battery on board. So it cannot be connected to like ICE engine, like the hybrid engine, or it cannot be put together with some other method of powering the vehicle. So as long as a BEV, you need to charge it, and you cannot charge using solar and everything. It's not sufficient enough. So you need to connect to electricity grid. So that's my answer for that.
Wow, I didn't expect such in-depth answer from you. It's so much knowledge in this EV area, which I have zero knowledge in. It's really good to
I
that
started
you
with zero
you're
too.
willing to share. Oh, I see. Okay.
Mm,
So congratulations again for submitting your paper and getting your paper published in in LNS Springer Lecture Notes.
Thank you very much.
So you're welcome. So now we shall move on. Proceed with the next presenters, which will be Tuba Batu, Siti Hajar Abain, Prof. Rozaida, Lokman, and Ifan Javid. But as I have checked that they are not available in this room. Oh, actually, Irfan is here. Irfan, can you hear me?
Yeah, I'm Tuba.
Oh, you're Tuba. Okay. Oh, you're using the name because it
Yeah,
confused me. Okay.
yeah, I
So
was having
Tuba,
some.
so
Yeah,
Tuba, you present as Tuba or you present as Irfan?
yeah, I'm presenting the research article with ID 058.
I see. 058. Correct. So, Tuba, if that's the case, then we will not play a pre-recorded video. Instead, we encourage you to present even though you're using Irfan's ID. So now, please kindly try the share screen function so that we know it's working.
Okay.
Thank you. And you have 20 minutes to present, which is until 3:43 p.m. Malaysia time, including your Q&A session. All the best and good luck.
Okay. Thank you so much. So, is my screen visible?
Yes, it can be seen. Thank you.
Bismillahirrahmanirrahim. Assalamu alaikum and good evening to everyone. My name is Tuba Batul and I am presenting the research article with the name Filter Method Feature Selection Techniques for Solid Waste Prediction based on GRU Deep Learning Model. So the co-authors of this article are Siti Hajar Arbain, Rozaida Razali, Lukman Hakim Ismail, and Irfan Javed. So here is an overview of my today's presentation. First of all, we'll have a look on the introduction and then purpose of the conducted research, then research literature review, and then we'll discuss the methodology and experimental results, and in the end we'll discuss the conclusion. So let's formally start with the introduction. So what is actually municipal solid waste? So any garbage or solid waste that is coming from any non-industrial activities, either that is coming from households or from organizations, that garbage or solid waste is known as municipal solid waste. So we need to understand, first of all, that why is it important to accurately predict the municipal solid waste generation rate. So to understand this, we need to know the impact of municipal solid waste on our environment. So as we know that it's an era of urbanization, so with the rapid increase in the urbanization, municipal solid waste is also increasing every single day. Its rate of generation is increasing every day. So it's very important to have a proper framework to handle this waste. Otherwise, we'll have to face the consequences in a way that our environment will get degraded, and then we'll have to, that would lead to the degradation of our lifestyle. So if we could accurately predict the municipal solid waste generation rate, so it could help the municipal authorities in many ways. For example, it could help the municipal authorities in developing a sound framework. They would have idea that how much waste is going to be generated next, so how they are going to deal with that, how they are going to collect that. So they could develop a sound framework to handle this municipal solid waste. So different studies have been conducted regarding this municipal solid waste generation prediction. Some researchers have used regression models. Some researchers have used time series models. So according to a study, time series model has performed better over the other models when it comes to the municipal solid waste generation prediction. Also, neural network models have been used, and recently long short-term memory LSTM and GRU models have also been used. So I also have used GRU model, which is gated recurrent unit model. So what is gated recurrent unit model? This is the most recent deep learning model, and it has a gated architecture, and it has the least number of gates. So it gets the least number of parameters. It has only two gates, a reset gate and an update gate. So the purpose of reset gate is to forget the unnecessary details from the data, and the function of update gate is to maintain the most important information in the data. So now GRU model doesn't have the ability to retrieve the best features. Like if I want to predict something, whatever input I will give to the GRU model, the model will get trained on that and will predict accordingly, irrespective of the features are good or not, they are suitable for that prediction or not. So GRU model is not capable of selecting the best features. So to improve the results of the GRU model, we have to use some feature selection techniques. Now, in this research article, I have used a filter method, feature selection techniques, and I used different feature selection methods, and because there were many studies conducted for the municipal solid waste generation, but they randomly chose the uh, features. They have never used any, or even if they have used any feature selection technique, they never compared them. So it was hard to say that when it comes to the time series data, which feature selection should be used. So I used different feature selection techniques to compare that which feature selection technique is best for this type of data. So this is the purpose of the study, which I already have mentioned, that the comparison of different feature selection techniques and the comprehensive evaluation of these methods based on the GRU model, so that we could come up with the best feature selection technique for the time series data. And then, of course, the prediction of municipal solid waste generation based on those. So here is the literature review. Many researches already have been done on the solid waste generation prediction. So here are models, for example, RN and LSTM models that has been used in a study, and that used the evaluation matrices, root mean square error, and a coefficient of determinant. Then another study was conducted that has used GRA, GRU, and then multi-site LSTM, CNN LSTM, bi-LSTM, RN, and GRU. So there have been used many different models, but we could see that when GRU model was used, RN GRU model, that was come up with the least error values. As we could see here, the MA value, mean absolute error value, that was 0.014, and the mean square error value was 0.0010. So GRU model is performing better over other models when it comes to the solid waste prediction. Now we have some filter method feature selection techniques in solid waste prediction. So feature selection techniques, as I already have told, feature selection techniques have been used with different models, but they have not compared so that we could come up with the best feature selection technique. So the feature selection technique here, our research has used Pearson correlation coefficient with artificial neural network. And this study has used the evaluation matrices, root mean square error, and coefficient of determinant. Also, mutual information has been used, and analysis of variance
Sorry
ANOVA.
to interrupt, to Babatu. Sorry, it'd be nice if you can turn on the camera so that we can see you presenting.
Okay.
If you are okay with that. Thank you.
Yeah, sure. Okay, so here we have the filter method. As I already have discussed, that we have Pearson correlation coefficient that has been used with artificial neural network, and then mutual information MI that has been used with LSTM, and then analysis of variance has been used with ANN model. Now this is the methodology. In methodology, also you could see the general workflow of the study, where raw data was collected, and then feature selection techniques were used, and then based on the values of those feature selection techniques, the features were given to the GRU model, and the GRU model was trained, and then it was tested based on the evaluation matrices. I have used coefficient of determinant, root mean square error, and mean absolute error, and finally municipal solid waste prediction was predicted. So municipal solid waste was predicted. So first of all, data collection. I have collected the data from OECD website, which is a website. Every data is available there. So I do have collected a raw data from that website, from where I have collected different features. About 15 features I collected for 15 developed countries. So there were about 256 total instances of my data, and I gave those features to the different feature selection techniques. Like I have compared the Pearson correlation coefficient, mutual information, and analysis of variance. So based on their values, I retrieved the subset of the data, and then I gave those subsets of the data to the GRU model. And then, of course, the GRU model was developed, and then it was evaluated based on the evaluation matrices. So here are the results I come up with. Here are the values of mean absolute error and root mean square error for PCC, MI, and ANOVA based on the GRU model. So we could see here that Pearson correlation coefficient model that gave us the best subset of the data, because GRU model has given the best results when it was given the subset of the data that we get from the PCC. So you could see here that MA and RMSE values are least for PCC GRU model. So the least error matrices values means your GRU model, your model is performing better. So PCC GRU outperformed, and then MI GRU, and then in the end we got the values for ANOVA GRU. So here are the values of coefficient of determinant, regression values for correlation coefficient for MI GRU and ANOVA GRU. So again, the least the value of error matrices, higher will be the value of GRU, and higher the value of regression, higher will be the value of GRU. So the regression value for PCC GRU is the highest, as we could see, it's 0.939, and for MI GRU it's 0.90, and for ANOVA it was 0.88. So the highest value was obtained for PCC GRU. So again, PCC GRU has outperformed here. So here's a general overview of the prediction that we have obtained for the PCC GRU, and the red lines and the blue lines, the red line is the actual data, and blue lines are the forecasted data, forecasted GRU results. So we could see that there are very minor differences. So PCC GRU has evaluated very well. So in the end, the study has contributed in revealing the importance of feature selection techniques, making the right choices in a sense, so that now, as I have presented the comparison of different feature selection techniques, so now in future, if someone would have to select a feature selection for their model, they would have an idea that which one is the right choice when it comes to the time series data. And then its influence on the accuracy of models prediction. The study has compared commonly used filter method PCC, MI, and ANOVA to come up with the most effective filter method techniques for the prediction of municipal solid waste generation. The GRU model has been developed for the prediction of municipal solid waste generation based on the features selected by PCC, MI, and ANOVA. And then in the results, we already have concluded that PCC has performed better than the other two approaches. Thank you so much.
Thank you, Tuba Batu, for your wonderful presentation. I keep forgetting the name because I only see Ivan Javid's name on your screen. All right.
I'm so sorry,
Now,
I had issues.
it's okay. So now may I ask everybody, if you have any questions for Tuba's research, you may type it in the chat room so that I can read it out for everyone. While we wait for the questions, let's see if you have any spare time for the Q&A. I believe you have another 5 minutes for Q&A. So since no one is asking right now, oh, we have one question finally. Okay, actually we have a few questions. I didn't notice, sorry. The question from Shari, that's not a question, sorry. The question from Nur Aida binti Husaini. She asked, what motivates you to do this topic? Do you mind sharing?
How
what
many
motivates
months?
you? Sorry?
Sorry, what was the question?
What motivates you to do this research?
It was my initial research, like it was my initial time. So I took about 3 to 4 months, I guess, particularly on this research article.
I see. It's a rather short answer. Do you have any other details that you want to share? Like perhaps you face some challenges while you do this research, technically,
Yeah,
or maybe you do. What are they?
The major challenge was the data collection.
The
So
data collection.
yeah, the data I had to collect, it was really hard to collect. I consulted so many websites and Kaggle and other databases we do have. I tried to collect data from different municipal authorities, and I tried many other ways, but in the end I ended up with the data set. About like the major time I spent on during this research, that was on the data collection. So after so much research, I reached to the website. That was the OECD website, and there I could get so much of the relevant data I needed for.
Oh, I see. Maybe is it okay to ask? Maybe you might want to share the website that you got the data if anyone is interested, because I myself have the same problem. I'm doing data mining as well, and I noticed that the data sets online, which is free for everybody, usually they are kind of old data, which is quite obsolete and it's not up to date. So I
Yeah.
realized that most of the paper, if they have new data or they collect them themselves or they generate them themselves, they are not really sharing the data source. Maybe because of the collaboration of the research
No,
with another, let's say, institute or private company, I'm not sure. But you are right. Data collection is so hard.
Yeah, I do
Especially.
have shared the source in my paper. I do have the website link in my paper. I
Wow.
do have mentioned that.
I see. So we can read and we will know what you get your data from. Okay.
Yeah.
So thank you for sharing and congratulations again for publishing your paper in LNSN Springer. So now we'll proceed to the next presenter, which is, I believe, the last presenter in our session before we end today's slot. So may I invite Ms. Ashikin Ali, to start your presentation with the title Convolutional Neural Network using regularized conditional entropy laws, CNNRCOE. I'm not sure how to pronounce. Please teach me how to pronounce that for minced handwritten digit classifications. You may begin your presentation and make sure the share screen function is also working.
Yeah,
and your
let me
mic.
try sharing my.
Okay, all good.
Okay, hold on.
Yeah, good luck.
All right. So you can see my screen, is it? Is it functioning?
Yes, can be seen.
Okay, so thanks to our respected session chair, Yap. Assalamualaikum and good afternoon to fellow researchers in the session. So I am Ashikin, one of the representative from the other two authors as well in this paper. So I will be presenting my paper entitled Convolutional Neural Network Using Regularized Conditional Entropy Laws, or called as CNNRCOE, the acronym for MNIST Handwritten Digits Classification. So this will be my outline for the presentation today, which is introduction and some current works, and also the proposed idea, results, conclusion, and future works of the study. So basically, classification is a type of supervised learning in machine learning. And the goal of it is always to predict the category or class label of an input sample based on its feature. You hear me? Can you hear me?
Yes, we can hear you.
All right, all right. I thought I thought my mic has problem. All right, so okay, back to the presentation. So obviously, it's like to predict category or class label of an input sample based on its features. So it involves training a model on labeled data set where each training example is associated with a class label. So the model also then learns to predict the label or on unseen data or examples. Okay, so it's like that. This is what we call as the generalization part of the model. So this study actually focusing on the
I'm sorry
generalization
to
part.
interrupt.
Yeah.
Miss Ashikin, I think it's better if you can enter the presentation mode, because now what we're seeing is the editing mode.
I'm actually on presentation mode.
Oh, then I think have to share the entire screen so that we can see the.
Okay, hold on. Okay, now do you see? Wait, now?
Yes, now can be seen clearly.
Okay.
Okay, thank you. Sorry to proceed.
Okay. So, okay, that is the generalization part of the model. And there are three types of classifications. Like first is like binary classification, where we have more than two classes normally. Two classes, not more than two classes. That is binary. And then they are multi-label classification. Multi-label classification normally involves like image with two categories, or a simple example like we can say a movie, like one movie normally have more genres, so that is what we call as multi-label. And the last one is the multi-class classification. So multi-class classification normally like there are like more than three classes. So let's say like there are like multiple animal classification, fruits or something, and the most common are digit classification. So that's the domain that we have choose for this study. So basically, handwritten classification is one of fundamental tasks in the field of computer vision and machine learning, because it's quite crucial though, because somehow it relates to real world scenarios. So it serves as a benchmark problem where which allows researchers to test and refine their algorithms. And normally, the benchmark providing to us to improve to us to improve our algorithm. So make it a critical stepping stone towards more complex tasks such as handwritten text recognition, image classification, and object detection. So the ability to accurately classify these handwritten digits is also directly applicable to real world scenarios, like I mentioned earlier, like such as for automated mail sorting, bank checks, processing and digitizing old documents. So somehow every handwritings are related to all these real world scenarios, you know. So since we have so many plagiarisms and whatnot of issues in this current world, so somehow it's very important. All right. So the commonly used model to perform such tasks are normally deep models. So the most popular or specifically used are convolutional neural network, or we call it CNN. Okay, CNN is like very popular and very commonly used. I think it's like vastly used by many researchers somehow. But in certain cases, not to say certain cases, somehow it is often criticized, which is CNN is often criticized as a black box due to its decision making process, which is not transparent all the time. So apart from being criticized, CNN also have unveiled major issues that always been a room for of improvement or exploration for researchers. So these are some of the current issues that related in that CNN been having in classification tasks. So the fast increment in the size and nature of current data sets makes very difficult for the algorithm to perform classification tasks efficiently. So that actually like rapidly increase the issues in overconfidence, overfitting, underfitting, memorizing training data noise rather than generalizing features. So like I mentioned earlier, the focus of the studies on the generalization part, because when it memorizes a lot, it doesn't give good generalization to the model. So which this results in poor model performance. So obviously you can see from the image that I have shared, like what is underfitting, balance and overfitting. So the focus is always on the balance part, and the focus issue of this study is on the overfitting part. All right. So overfitting is somehow related to the loss function use or the loss function selection of a CNN model. So in any machine learning task, the choice of loss function is always crucial and directly influence how the model is trained. So the traditional loss functions like cross entropy have been widely used in classification tasks, but however, they might not always be optimal because it effectively penalizes incorrect predictions by assigning a higher penalty when the model is confident but wrong. And somehow the issues that I have highlighted earlier is still there and still a room for improvisation. So that's the reason, one of the reason that why we explore or we try into a new modified loss function in this study. So then it's like always an eye opener for researchers in the field to come with state of art approaches by fine tuning the loss function. So this can be better align the model's learning process with specific challenges of the task at hand. So next, so these are like some of the current limitations or advances that I've determined. Like okay, from cross entropy, these authors like Wang, Demirkaya, and Feng, they mentioned that CE merely causes overconfidence and overfitting due to deficiency on class imbalances, non-robust to outliers, and sometimes they are over-parameterized, and normally there will be like serious overfitting on noisy labels or poor generalization. And on the other hand, on conditional entropy, like authors like Fisher, Fan, and Su, they have actually used this in different deep learning models, like in GAN, autoencoder, and some other deep learning models. So it is proven that it is conditional entropy or like mutual information based, highly informative with no jeopardization onto the data, still effects on robustness and generalization and generalization of the model, and it is less implemented on CNN deep model. So that's the idea of why we come up with the idea. So in most papers, like most researchers like opted on future works to work on optimization or regularization technique in order to mitigate the generalization issues in the deep model. Okay, so in my case, like there's no like specific optimization technique used because my whole focus is on a loss function, where we add on the regularization penalty to the loss function. So to address the limitation, we actually introduce a modified loss function called RCOE, or regularized conditional entropy loss. The idea behind this is to incorporate regularization directly into the loss function. So regularization actually helps in preventing overfitting by encouraging the model to learn more generalized patterns rather than memorizing the training data. So RCOE adds an additional improvisation to the traditional conditional entropy, where loss that penalizes the model for overly confident but incorrect prediction. So by doing so, it really improves classification accuracy, and particularly on challenging or ambiguous samples. So in this case, we use handwritten digits, not only like one type. We have a variation like where we have rotated images with background. So there are some noises and all that. So in this case, like we also try to use that kind of data set to see on how this works on our model, right? So we hope that this approach not only aims to enhance the performance of CNN on MNIST classification, MNIST handwritten data classification. We really hope that it opens new avenue for researchers to research more into loss functions that are better aligned with challenges of real world data. So like basically like we can try with different domains. Like even I have the idea of that in my future works, like to work on different domains other than this. So the visualization here is like the proposed idea of this study, where the visualization aligns input to represent the raw input data, where we have grayscale images of handwritten data, which we normalize to 28, and those are benchmarks. So it's like originally that way. And in this case, like we don't just use one MNIST data. We used sorry, I wrongly exited my presentation mode. Sorry. So it's like it starts from the raw input, and then the MNIST, which is the MNIST handwritten digits, inclusive of 5 variation data set, and convolution layer actually represent the performance of convolution operation on the input data to extract the features, and Boolean layer will downsample the feature maps generated by the convolution layers, and then there is a dropout in the model to actually which is applied on the pooling layers to prevent the overfitting, and the flattened layers as the output from the previous layer into a vector, and fully connected layer which takes the flattened vector and learn to classify the input. So here is where the RCOE layer computes the regularization conditional entropy, which involves the conditional probability distribution of the networks prediction given the input data, and is regularized by some entropy measure. So output layer produces the final output of the network representing class probabilities. So this is basically the idea of the proposed work. And we have results, conclusion, future work. So from the result that we have obtained, I actually improve a work by Shu, one of the author, where they actually uh, managed to obtain 72.46% of accuracy, which and we have increased in this study. We have increased almost a perfect accuracy where there's increment by 20% of accuracy. So actually the 99% works on the very first data set, which is the MNIST data set, the whole handwritten MNIST data set, and the rest we have like rotated images, we have random background images, and we have with background images, and the last one with rotated and back images. So and it's like evident that the loss function that we propose managed to give a better improvisation as compared to the traditional cross entropy or conditional entropy. So in this case, we actually examine with CNN with cross entropy and the RCOE. So this is the outcome of our finding. And as a conclusion, from the outcome we obtained from the study, like this, the integration approach of conditional entropy and regularization managed to improve the classification accuracy of CNN on MNIST variation dataset. And somehow there are several avenues for future research and improvement somehow, because it may work with this data set and we don't know whether it will work with other complex or larger data sets. So that would be an opening for other researchers or me as well in future. So my future works is like there is an idea for me to try it with different regularization techniques or L1 or adding more noises, and trying with different domain, for example, like using explicit contents or violence contents, which was my initial idea of research. But this algorithm was not favorable to my idea of violence content. So I had to do some changes. So it might be my future work to try with different domain. And then also like trying with different deep learning models, like other than CNN, we can integrate RCOE with different deep learning model, inshallah, in future. And also to examine on different log-based or logarithm of entropy. Log-based means like it's commonly used is like log-based 2, right? The log-based E or net, we call it. So we can try with different other log-based also. I mean, in order to to produce smaller values that make the loss value easier to interpret somehow in future. So that is the ending of my presentation. Thank you so much for your time for listening to my presentation.
Thank you, Ms. Ashikin, for your presentation.
Welcome.
Again, I would like to ask everybody, please, let's put on our thinking hat and we can together ask some questions to Ms. Ms. Ashikin Ali's research. Perhaps you want to know what challenges she faced. But this question I already asked multiple times, so I'm not going to ask this again. But please, if you have any questions, do write it in the comment section, which is the chat room, so I can read it out for you. In the meantime, we have one question. What are the limitations of using regularized conditional entropy loss in CNN?
Okay, one of the potential increase somehow there's some computational complexity due to the added regularization term, but somehow I managed to, I mean, like we have a proper, if we have a proper fine tuning to the regularization parameter, so I believe we can mitigate that too on the computational complexity part. So, and another thing is like what we can say is like obviously models performance or how to say, it's like it may vary depending on the nature of the data sets, right? So that is another thing. So it might work on this and it might not work on that, but the limitation is like actually on the fine tuning of the model and the parameters. So that's where it helps to mitigate the complexity on the computation. So I hope it's like helpful, the answer.
Thank you, Ms. Ashikin, for your presentation. Do you have more questions?
I don't want questions.
Oh, just now you mentioned that you also, for your future work, you plan to explore more on other deep learning algorithms. Maybe is there any specific algorithm in your mind? Like,
Depends on what the domain that you that will be selecting, right? So how it will work. I mean, which, let's say the domain, whether it's image or text or audio, depends. So if we can see which certain model based on the domain, so then that's how we can interpret it.
I see.
All
Good
right, yeah.
answer. Okay, thank you, Ms. Ashikin, and congratulations on publishing your paper.
All
So
right.
now let's proceed to the last presenter.
Thank you so much.
Thank you. Welcome. The last presenter, Mr. Shahab, will begin with his presentation entitled An In-Depth Strategy with Deep Generative Adversarial Networks for Addressing the Cold Start in Movie Recommendation System. Interesting title. Mr. Shahab, are you ready? I can see your slide. Perhaps you can try to enter the presentation mode. Where, did you just left? Can you enter the presentation mode, Mr. Shahab?
Yeah, hello, yeah.
Hi, we can hear you, but we can't see you.
Yes,
Is it morning over there?
No, I'm
I
here
think-
in Malaysia.
Oh.
Yeah.
I didn't know Malaysian chicken
No, I
are
have
working
family
at this
here.
time.
No,
I can.
actually, no.
Okay.
Okay, I just
Perhaps you can try to share the entire screen so we can see the presentation slide.
Entire screen, okay. Actually, we didn't use before this. I always use the another tools. Have you seen my screen?
Yes.
Okay.
All good.
Okay, let's
Okay, all
start.
the best.
So first of all, everyone, just humble welcome to the sixth international conference on soft computing and data mining, SCDM 24. So my name is Muhammad Shahab. My title is in a deep strategy using deep generative adversarial network for addressing cool start problem in movie recommendation system. And my co-author is Yana Mazwin, Muhammad Hashim, and Rozaida Ghazali, Irfan Javed, and Nourizi Arbe. So let's start from the outline. So here is the outline of my presentation. First, we begin from overview, just a bit overview on recommendation system, cool start, and generative adversarial network. Then purpose, then research workflow, methodology, experimental results, and key findings, in conclusion, and future works. So let's start from the recommendation system. So first we have to know what is like a recommendation system. So basically recommendation system is just tools to you see to suggest something if you are using like a website, right? So the behalf of the website, we just watching like browsing history, right? We browse something, then you can just like something or just I just example give you example of Netflix. If you're watching a movie, if you're watching a movie, so the Netflix backup, if they have a recommendation system, right? So they will see your browsing history and your interest and like your fast behavior, just like a browsing history. So because so they will just judge your behavior and they will recommend you the movie the behalf of your browsing history and interest. Now it's come to the cool start problem. So cool start problem is actually when you enter like a new user to Netflix, right? So it's really hard to recommend a movie. I will always example you a movie because my work as in a movie. So this will be much better for me and us. So when we come to the movie, so if like there is two problem like user and items. So if you come to like a new user, you don't have a data, so it's really hard to just like to to suggest, to recommend something, a movie, sorry. So it's really hard. So this is the cool start problem occur when there is no rating, no data, no watching history. So it's really hard to recommend. It's up to Atom. If we just like if you upload one a movie, they don't have a rating, they don't have a watching history. It's really hard to suggest to user. So this is the basic like a cool start problem. Now it's come to the generative adversarial network. So generative adversarial network is consists of two a network, generator and discriminator. First I just tell you this is the standard architecture of the GAN. So first we pass the noise data to the generator. They generate the synthetic data like a fake data and pass to the discriminator, and also we pass the real data to the discriminator. So discriminator just play adversarial game, like they play if the data is correct or not. So if the data is correct, so they will just pass the value. If not, so they will reloop this value and update the weights, like they come to the generator and up to like a discriminator and reloop this methodology. Like so, this is a just short overview on generative adversarial network and recommendation systems. So now I have to do my proposed model. So what we have to propose, like we address here the start code problem and recommendation system. Then we integrate CF collaborative filtering with SVD, singular value decomposition, and generative adversarial network. Then we enhance this with the content-based filtering, and we used in content-based the feature like genres. Genres, like we watching a movie, so they have a genre. Some have a like funny movies, some have comedies. Sorry, that's same. Some have a like a fantasy, some have an adventure, and we improve the accuracy of the scenario with limited item data. It's come to like this study is about items, not as user. So if there is any item like movie, they have a limited rating, so we have to tackle this problem, right? Then analyze the integrated model performance. So it's come to the research workflow. So research workflow, we have like three phases here. First phase, we data preparation, like a data, how we load the data and what data processing. Then we come to the second phase, the proposed model development, like IGAN. This is we develop here IGAN, so integrated GAN. And then come to the third phase, we have to do this here, the research and analysis. And then come to the methodology. It's the like the so methodology, like we have to first step, we have to data preparation. Okay, so data preparation, we first take the data set from the movie lens and focusing on items and movies, because we have to tackle the cool start problem in items, not end user. So we just here to focus on movies, not end user. And then we come to the data cleaning. So data cleaning, we just perform like we have to tackle with these we have to just like to skip those movies. They don't have a like they have a null video, sorry, they have a null video. Then we visualize for that, because we have to see which movie have a most rating, which have a minimum, which have a middle. And then we split the data, we split the data in 18% and for training and 20% from testing. And here you can see then the data set, we just show the diagram, data set, then data cleaning, data, and then data visualization, then data splitting. Now it's come to the another step. So the next step, we just use the collaborative filtering with singular video decomposition. Sorry, I just want to I just forgot to on my pen, so sorry. Sorry, everyone. So now we come to the model training. So in model training, we just first step, you have to collaborative filtering with singular video decomposition. So here we use the user item matrix for unrated items. So predict unrated item. Like we have a movie, they don't have a rating, so we have to predict here the unrated movie. So And this actually this process is just help to like when we have a movie and they don't have a rating or less rating. So here we find those movies and then come to the gain training. So gain training is work like that. They have, I just tell you, in the standard game the same as like that, but we have to just enhance something else. So in gain training we use generator, we just pass like synthetic rating, right? A random noise. This is a random noise, not like actual rating. They just a random noise, and we use multiple layer with leaky relief activation function, and with sigmoid activation function. And discriminator, we just like they differentiate. I just told you before in standard again. They just differentiate between the real data and the synthetic data, the fake data. So there is also we use a leaky relief activation function for improved learning. So the out will be like a probability being real or synthetic. Like being real, matlab not like a real, but it's look like a real. Okay. So adversarial, here is actually the generator have, I just tell you before, sorry, in the standard game they have a adversarial process. So a generator creates synthetic ratings here and pass to discriminator, and we pass the actual rating to the discriminator. So he play here the adversarial game. If the rating is look like a real, so they generate, so we pass those rating we generate by the generator. So after this, we come to the integration again with collaborative filtering with the SVD. So here we combine the both outputs. The predicted rating we just predict in the SF's SVD with unrated movies, right? And the synthetic rating we generate by generator. And behalf of this, we generate a single movie to a specific user. Okay, so now as you see, there is only a single movie. So still we have a user cold start problem. If a user, like I just give you example, if a user watching a movie, just they just now we just watching a movie and recommend this one movie behalf of the previous movie, the fake rating. So it's just a single movie. So we still have a cool start problem. So we have to tackle now. So I just use here the content based filtering, use the generate from primary attributes, like I just tell you, like this we generate the fake movie here, like Toy Story. So Toy Story is like adventure movie. So this is the genre. So we just here focus on genre. So the for genre we use the term frequency, inverse decrement frequency, and the similarity cosine. So here we just focus on these this genre. So behalf of this we just present the, like you see here, the TF-ID vectorization and cosine similarity. We just present here the recommend movie descriptive list, like a full list of this, because they have many movies is like adventure movies. If they have adventure, like Toy Story have adventure movies, adventure movie is many more. So we have recommend a descriptive list. So here we just tackle the problem, who start problem. So now it's come to the experimental results. So here I use the precision evaluation matrix, precision, recall, and F1 score. So precision is just work like a measure to correct the recommendation system to a proportion of relevant item among the recommended ones. And recall, the model ability to identify all relevant item within a data set. And F1 score provide a balance between precision and recall, offering a comprehensive measure of the model's performance. Now it's come to the performance comparison. So here you can see the graph, right? So the generator last we have like indicate how we will create a realistic data. Like if the we creating like a data that look like a fake data, right? And generator. So if the data is like totally fake, so they recreate and they reloop. So that will be much last here. So as you can see in generator is like the orange line one. So it's really less loss. So and now it's come to the discriminator. So how accurately he discriminator identify this is like real or fake. So as you can see, the blue line one, it's also just like the generator loss. So it's really close. It's really accurate to compare other model. So now it's come to the compare with the other model, the existing. I just compare with pool gain, sample gain, and CDA, and MMF and coffee gain. So here you can see the results I just show in the graph. The integrating CF, SVD, and gain model show superior performance. Right, you here you can see the simple gain is 0.09, and like you see 0.33, and you just see the proposed method is 0.85. So it's really, really accurate than another one. And now you see the F1 score and recall is really accurate to the previous one. Okay. So now it's come to the key finding. So actually, key finding here, we have effectio, like you see the results, you see the methodologies, we have really good results to tackle the co-star problem using CF as SVD prediction. We have improved recommendation accuracy, enhanced ability to make accurate recommendation even for item with limited ratings. So we already tackled this and fertilize the recommendation system. So combine SF, SVD with content based. So we just recommend a descriptive list to the user, a specific user, because we tackle here the items. So we have to don't we have to just focus on item here. So I just select a specific user. I just like ID one, so I just select a one. Okay. And the scalability and versatility, the performance approach is adaptable. Different data set can be applied other domain beyond movies such as a book. So now I'm just working. I already work on book recommendation system, and have you have go to the e-commerce and the music. Okay. So this is the conclusion and future work. So the conclusion is that, and we first that we already tackled the post-star problem and recommendation system by integrating collaborating filtering with SVD and GAN with reactivation function, and we improved the accuracy combining a CF SVD with GAN generated ratings. Like we use already generate rating by GAN and refining the content based filtering. Here is much future work we have to use, like more data set. As I just tell you, I already work on book. There is book music, there is a commerce, this is Netflix, there is many more data set they can use. Improve feature they add advanced feature like NLP for better text analysis, like they use the review of users, the review are good or not, so they can use also this. So this is for a future work. Use new technique, explore method like transformer for more accurate recommendation, and least scale and optimize. So make model hand larger data set. So there is many more larger data set they can use for future work. So thank you everyone, and sorry because I didn't on my pen, so it's really sorry everyone.
Thank you, Mr. Shahab, for your wonderful presentation. And you don't have to apologize.
Yeah, thank you, bro. Yeah.
Okay, so you being the last presenter, I believe we have still a few minutes before we end the session. Maybe if the participants have any question, you can write it in the chat room, and then I will read it out for the presenter to answer. In the meantime, what in the meantime do you want to share with us? Like whether do you have any future plans that it's not written in your paper, like you have some secret plan to maybe apply your work somewhere else, or to further enhance what you did? You have any plans like that you
Yeah,
mind sharing?
Yeah, actually, yeah, as you see, the recommendation system is like a really general topic. So if you come to if you really understand it, but if you come to recommendation system, it's really hard because there is many work on the recommendation system, many more. I just taken this problem, I just see many paper, I just see many things. So now I'm want to work in the recommendation stuff. If I do my PhD, so I will take this topic because there is many new techniques come to, like as I told you, we are come if you want to come and review. So review is really good topic for I want to study on that because
A
now you
review.
see, yeah, because as you see now, like Shopee, I just give you an example of Shopee. Now you see if you are doing a shopping, right? So everyone just look it on review, not like how many buyers like that. So this is like
Mm.
a good step for future.
Yeah, good point. So thank you for the wonderful answer. And since we received no further questions in the chat room, I believe we have to end this session. But before we conclude, I have to say, oh, sorry, we received one question. What do you mean by cold start? And which specific platform used to gain the data sets? This is a
Ex-
question by Ashiki Ali.
yeah, okay, thank you. Actually, it's quite simple. Like if you want to take a look stuff, you have to first, like there is a general website like Kaggle, right? Everyone knows about that. So you have to just come to the Kaggle and you can just search about a website, but it's really difficult to find those data set. They have a cool start problem. It's really difficult because first I just download mini data set, but I just when I just come to the cool start problem, they are like they have a user, so they have sorry, there is a movie lens data set, mini data set. If you come to the movie lens, there is mini data set, they don't have a limited ratings, so it's really difficult to find those data set. They have a limited rating, so you have to search on Kaggle. So if you have any question like that, so you can ask, but it's you can just come to the Kaggle and you can find Kaggle. But core star problem, as I just tell you, core star problem is a that they have a limited ratings and items. If they have limited watching history, behavior like that, user have also a core star problem. I just tell you these two problem, core item and user. So if you have any relevant question about this, so it will be much better because your answer, I think you get your answer.
Did you get your answer? I think so, Miss Ashiki. If not, please write more questions to further asking. Okay,
Thanks
before
for the explanation anyway.
Thank
she
you.
understood. Well, I believe it's time for us to end this session. Before we conclude, I have to say I didn't expect to hear a special guest during the session, a rooster making a surprise appearance by sound. So has certainly added a unique touch to our discussion. So that's all. And not to forget, we have a fruitful discussion about me, the participants and the presenters. So thank you to all the presenters for their insightful presentations and to the audience for your active participation. It's been a productive session and I hope you've gained some valuable knowledge from today's sessions. Before we wrap up, I would like to remind everybody that the conference continues tomorrow with more exciting sessions. We look forward to seeing you all there for the closing ceremony as well tomorrow and more parallel sessions. Once again, thank you and enjoy the rest of your day. See you.
See you. Bye bye.